Okay, so we're recording. Okay, I'm going to start. Good morning, everybody. Thanks for tuning in. This is the 2022 Oregon CyanoHABs Stakeholder Meeting. We've been running these meetings for quite a number of years. They were started by OHA, the health authority, when they were a little bit more flush with funds. And for the last few years, I, as the president of the Oregon Lakes Association, and through my connection at OSU, Oregon State, have been hosting it. So welcome again. And so we're presenting this through Oregon Lakes Association, Oregon State University, with Oregon Health Authority and Oregon Department of Environmental Quality. And we'll be hearing from people from those agencies as well as some others. So let me just start with a few introductory slides. You've all seen the program. Can everybody hear me loud and clear?
Yes.
Yep, okay, good. Yeah, just I would like to say, please mute your microphones so that we don't have background noise coming in. There will be time for questions through the program at various points. You've seen the schedule. When it comes to questions, you can either try the chat or raise your hand, but we have so many people, it'll be hard to find a hand. So you can unmute and just chip in and announce that you want to ask a question. I think we can probably figure it out, but don't be shy if you're being overlooked to just unmute and fire off a question. So the intention of these meetings has been and is to bring together people in Oregon who are interested in the cyanobacterial blooms that are occurring in our lakes and reservoirs. And our format is to recap the past season, look at particularly regulatory requirements that might have changed in the last year, and go over an outlook for the next season. So I just want to briefly introduce again Oregon Lakes Association. I think most people are aware of our group. You can visit us at the link, the web link up on the top right. So it's a group of volunteers who have chosen to work on a few sort of key activities. We raise money and provide funds for an annual scholarship to support graduate students who are working in Oregon on issues that are important to Oregon lakes. And so we're quite proud of that. And the signature sort of issues that Oregon Lakes Association has taken on are the CyanoHABs, and that's the reason we're presenting this stakeholder meeting, and Lake Abert and dryland lakes. And that's a conservation issue dealing with this lake that is shown here in this picture that is in southeastern Oregon that has been dry this year. It was dry in 2015 and 16, and it was dry way back in the Dust Bowl era in the 1930s. But we're very concerned at the loss of habitat for birds like these birds on the bottom left. Oops, what happened there? Because this is a quite unique environment that is hypersaline. And the only other lakes of a similar type are Mono Lake in California and the Great Salt Lake in Utah. So if you're passionate about lakes, please consider joining if you haven't yet. To those people who are members, thank you very much. And to the extent that you would like to be involved, we invite you to do so. So here's the start of the program. And so after my brief introductory comments, we will hear from Oregon Health Authority and then from EPA. So of course, Oregon Health Authority has regulatory oversight for cyanobacterial blooms, primarily coming from the fact that a number of them can produce and do produce toxins. EPA, we'll hear from Rochelle Labiosa from the EPA office up in Seattle. EPA over the last few years has really stepped up and provided really good background information and can do how to deal with cyanobacterial toxin outbreaks in a very practical sort of way, and also has stepped up some research looking into the effect of toxins. We'll hear from the Forest Service and from the Army Corps of Engineers, and then from Aaron Borisenko from DEQ, we'll hear about the effect that increased funding from the state legislature has had on the ability of state agencies to deal with these cyanobacterial blooms. And I think those of us who have been attending these meetings for a number of years would remember that one of our last meetings, perhaps, I think it was 2017, the face-to-face meetings in Corvallis, at one of those, we really decided as a group to try and contact the state legislators and get some increased fundings for CyanoHABs at a time when that was sorely lacking. And so Aaron will describe how we've really made some excellent strides. And then we'll hear from Dan Sabota about some of the activities at DEQ. And after that, we invite people to chime in until about 12 o'clock on your experiences this year. This afternoon, for the first time now, we've developed a program where we have a number of talks, short talks, 10-minute talks, to go over the research that is going on in Oregon in regard to CyanoHABs. So in the past, we had just heard very briefly in the equivalent of this 11:20 to 12 o'clock session from activities, but really there's more going on now, and there are some real opportunities for people to get together. And so the idea is through these 10-minute talks, which will really just touch on issues rather briefly because it's quite a short time, to get an idea of what's happening, and that will allow people to see skills and interests in other researchers around the state and to make new connections. So my thanks to Dan Sabota and Lara Jansen who are also on the Oregon Lakes Association board in developing this program and this concept for this new afternoon session. So I think that's it. Thanks again for joining us. I think we'd be ready to go ahead and hear from the first speaker, who is Rebecca Hillwig from the Oregon Health Authority, who will talk about the 2021 CyanoHABs in review and about the program and give pilot project updates. Rebecca, you can share your screen and you can get started. I will note that we are recording these talks, and as in the past, we tend to have the slides deposited.
Okay. Hopefully my audio will stay good.
Gosh, Rebecca, your voice is
Yeah, Rebecca, you're really garbled right now.
Scrambled again. Oh, everybody, this happened. Rebecca joined quite early and her voice was loud and clear, and then it got scrambled and she signed off and joined again, and the same thing has happened now. We don't.
Should I call in?
Yeah, if you can call in, I think that'd be the best thing, Rebecca. The feedback is just too much. It's just too much.
We're a bit ahead we're a couple of minutes ahead of time already. We'll wait for you, Rebecca. We won't change the schedule.
Okay, can you give me the number?
Well, it's on that.
I'll post it here. Just give me a second.
Okay, thanks, Dan.
Theo, this is Aaron. If you need me to jump in to keep us on schedule, I can.
Yeah, well, we thought of that if it becomes a problem, but I think let's give her a couple of minutes to hook back in and keep the schedule as it is, Aaron. Now, who was that? Somebody else's voice is scrambled.
Yeah, thanks, Amalia.
Oh, wow.
So should be posted.
I have not come across this before. No.
I can jump in if you need me to, Theo.
Yeah, Aaron, let's just give Rebecca a couple of minutes, see if she can get back quickly and see if we can fix it. Otherwise, we'll we'll probably have to go ahead. Greg, are you signed up with us? Greg Baird? Yep.
Yeah, Theo, I'm here if you need me to go.
Okay, thanks.
Welcome to Zoom. Enter your meeting ID followed by pound.
Rebecca, can you mute yourself?
Sorry, just a sec.
Turn off your computer microphone.
Do you guys have the code?
It's on the chat. If you open the chat window, and now you're of course clear now.
Yeah. You are. We can hear you clearly.
Me.
Okay, Rebecca, are you with us again? Okay, everybody, we're just to catch you up. We're about to start the program, but unfortunately, our first speaker.
All right, guys, you might want to have Aaron go first, and then I can go after Aaron.
Well, why don't you go ahead now? It's looking fine. Can you control the? You sound really good now. Can you control your computer and?
Is my voice still garbled?
No, it's fine.
Yeah, maybe make sure you mute everyone because there may be some feedback getting onto Rebecca's computer that's causing this.
Okay.
Sorry. There was a code that was, and then it said the meeting ID. So you sent me the meeting ID.
Can you not?
Can you hear me?
Computer now, Rebecca. Your slide is still showing.
Yeah. Here, I'm gonna stop sharing for a minute.
Okay. But I think you can go ahead now.
Oops.
Apologies, everybody. We're just having technical problems, and things were fine until they weren't fine, and so we don't really understand the source of the problem.
So can you hear me now?
Yes, go ahead.
Okay. I'll try to get through this. Oh, come on. So we had very few advisories in 2021. One, we had Upper Klamath Lake, J.C. Boyle Reservoir, Ross Island Lagoon and Holgate Channel, and Malheur Reservoir. And I'm not sure, most of the toxin analysis came back either very low or no toxins. And so I'm not quite sure exactly what happened last summer or last season, but I guess it's a good thing. So anyway, all the research out there hopefully will come up with some reasons why some of this stuff is happening. It was the first time that we had any sampling done in Eastern Oregon. We partnered with Oregon Department of Fish and Wildlife and the Bureau of Reclamation out there. They've historically had blooms, but you never had the resources to really help us with sampling and whatnot. So in coordination with DEQ, we worked with those agencies to get out on Malheur Reservoir and also Bully Creek Reservoir to collect samples. And they did send those in to DEQ for analysis. Unfortunately, there was an issue with the shipping from out there. It got delayed because the samples go to Boise, Idaho, and then back to Portland. So the samples were coming in over time in temperature. And so that was a problem. But the good news was that we were still, DEQ was still able to analyze the samples, and even though some limitations, it still helped us to know what was going on. They also, one good thing with the partnership was that ODFW actually was able to contact the Sheriff's Office with the county out there, Malheur County Sheriff's Office, to help with posting signage and doing visual monitoring. And maybe this next season, they might be able to help with collecting samples as well, since the rangers and whatnot don't get out there very often. As Theo said, there was some HABs legislation, and that happened last year, and it also happened in the short session this year. It was reintroduced in February, and unfortunately for OHA, that House bill died on arrival, so we did not get any additional funding, nor did DEQ, but at least DEQ got funding last time around. So DEQ and OHA, we have a meeting on Friday. Unfortunately, it couldn't happen earlier, but we want to talk about some different strategies about potentially doing more routine sampling, somewhat similar to the beach monitoring program that some people might know about, but it would basically be looking at all of the lakes in Oregon that are highly recreated, or lakes like Siltcoos Lake, where people are pulling drinking water through private intakes. So there would be criteria that we would look at and determine whether or not we could do some routine sampling on those lakes. So, maybe every other week, or, some sort of plan in place, so that instead of being sort of helter-skelter like we are now, it would be definitely more routine, and we'd be able to provide better information to the public about those water bodies. We have been using DEQ's applications, satellite application. They've been really gracious about sending reports, and pretty much they sent them weekly last season, which was extremely helpful, and it assisted us in sort of looking at the water bodies and determining what we really needed to do. Was there an issue? Do we need to contact the water body managers? And so it's been a real help, including the cyan data has been a real help for us, especially since it's local and it's just on Oregon lakes. And I think I talked about this before, but there is a potential for OHA to develop some protocol where we would actually use satellite data to issue advisories. We would still need the sampling to sort of back that up, and also sampling to lift any advisories, but it would be helpful if we could, have some sort of protocol in place to issue advisories when we see satellite images or other information that tells us that there is a harmful algae bloom on a lake and could potentially be producing toxins. And then I wanted to mention that ITRC, the Interstate Technology and Research Council, has developed strategies for preventing and managing HCBs for planktonic species, and that guidance has been out, I think, for about a year now. We've also, I was part of the development process for the same type of guidance for benthic species, and that guidance hopefully will be out in April. Both of those are extremely good, documents to refer to. They have everything from maintenance to risk communications. They have a video that helps people to identify what they're looking at when it comes to both planktonic and benthic species. And so it's just a really, really good tool for not just for people who already know a lot about HABs, but also people who are just learning about HABs. So a little bit about the pilot project highlights on Siltcoos Lake, and that again is the lake where people are pulling drinking water through private intakes. Those private intakes are not regulated, so they really don't know what they're drinking other than what the manufacturer has provided for the in-home treatment systems that they're using. So as part of a CDC grant, this is actually our fourth year, beginning of our fourth year for that grant. We developed a pilot project on that lake, and basically it's to educate and to reach out to the community to help them to understand what's going on in the lake and also what they can do to reduce their exposures. The money is also sort of earmarked for illness reporting, and so we've been really trying to get out to the community as best we can to find out, are there any acute illnesses that may be occurring, or even chronic illnesses, since they've been drinking that water for quite some time now, a lot of them. So we did develop a risk communications plan, and that plan includes a lot of different materials that are actually going through the publication process as we speak. And I think that they're going to be extremely helpful. They're very colorful and easy to understand. And so I think it's going to be really helpful for people, not only in that community, but once we're finished with that pilot project, those materials will be able to be used all across Oregon and any community where people are pulling water in private intakes. So those risk communication, those materials include a plan with guidance on how to engage the community, fact sheets, and the fact sheets cover owners of private intakes and treatment systems, renters, vacationers. We found that a lot of homes out there are either B&Bs or they're long-term rentals, so that also causes an issue. There are fact sheets for dogs and livestock owners. We've updated the ones that we've had in place. The fishing fact sheet that has been updated. And then we even have a PowerPoint presentation template that local government communities can use to educate folks. We have a comic strip for kids. We have social media posts that they can use and pluck from, depending on the situation. And then we also have a lot of templates for press releases and flyers and letters that they can use to send to their residents. And then, as I said, they're with our publications folks right now, and they're looking really good so far. We do have a community volunteer, which is really good. There's a gentleman that lives near the lake who seems to have some water quality background. And he used to go out and take pictures of the lake, and he does some water quality, just basic water quality analysis. So we get sucky depth and salinity. There's a big issue with salinity in Sulcus Lake, which could be one reason why the microcystin production and even microcystis is not what it used to be in the past. He's seeing a lot of aphanizomenon floss aquae, and there's not been any real issues with toxins, which has been a problem in the past. So not sure if that's the salinity issue or what, but anyway, he provides that information to Oregon Health Authority. So lots of photos. We get microscopy from him. We get water quality information, and then he is provided with test strips for both microcystin and anatoxin through the Susla Watershed Council. And so he also provides that information as well. So we've been able to really keep up with what is going on in the lake, not only visually, but also with any potential toxins. So again, that information allows us to really appropriately take action on the lake as necessary, and that would be in coordination with DEQ. So if there was an issue with a test strip that showed, toxins at a high level or above, the test strip indicator, then we would ask DEQ to go out and sample, and they've been gracious enough to do that for us. And they would also be, as we talk about routine sampling and the area that we would be looking at, or the lakes that we would be looking at for that routine sampling, I think Sulcus Lake would be a great candidate for that routine sampling. And this is just examples of the educational materials. They look a little bit different now since they've gone through, a couple of them have gone through that first blush of publications. But basically, these are kind of what we're looking at as far as communications to the community and for the local government to use to distribute to their folks on, especially those on private intakes. And I think that's it.
Thank you, Rebecca. You've put a lot of work over the last few years into this issue of these small communities with private intakes, haven't you? Yeah, good.
Yeah, we have.
Yeah, that looks really good. You mentioned the routine sampling, and of course, I also mentioned the stakeholder meeting at which we decided we wanted to talk to legislators, and one of the driving issues then was that the absence of such a routine monitoring program and the anomalies that come up, such as somebody happens to take a sample at one lake, and worst case scenario is it turns out to be toxic. A nearby lake is never sampled and thereby is never shut down, although it could have toxin. And so I would encourage you to think about that when you draw up the list of lakes, because that was, it's just an issue of unfairness and sort of unequal knowledge in a pretty close geographic region. But some of the private resort owners were impacted in a negative way, or could be, through that scenario, and that was a concern.
Yeah, that's good to know, Theo, and I totally agree. And I'm sure Aaron and folks at DEQ would agree as well.
Any other questions?
I'd just like to comment that I'm very, very encouraged that OHA and other people are paying close attention to the potential problems medically for people drawing water from silt goose. I've been concerned for many years about that. Does anyone know of any potential funding or monitoring capability by USGS interest in maybe monitoring silt goose for perhaps fish bioaccumulation of toxins over time? It just seems like that could be another step that would ideally be incorporated in the future to get an overall picture of perhaps toxin accumulation and effects for the fishery and as well as drinking water. But I would think that perhaps USGS could be encouraged to take a look at the potential for furthering HABs assessment in Oregon by looking at silt goose.
Yes, speaking of that, Leslie D'Ingalata just sent out an invite for a webinar that is dealing with cyanotoxins in fish and shellfish. And that's going to be on March 22nd. So that might be helpful, although it's not focused on, Silt Goose Lake or USGS. There's a lot of folks across the country who've been doing a lot of research in that area, and EPA has also begun looking and doing some, research as well. So I would, refer you to that webinar, which I think is probably mostly day, but sounds like a really interesting one.
Yeah, that sounds encouraging too. Thank you.
Any other questions or comments for Rebecca? Yeah, Megan?
Hi, everyone. Megan Skinner, Water Quality Specialist with U.S. Fish and Wildlife Service in the Klamath Falls Fish and Wildlife Office here. So I just wanted to comment that I started about a year ago a monitoring effort in the Klamath Basin Refuge Complex, focused mainly on the California refuges, so maybe not directly relevant to this conversation. But, you know, we did pick up saxitoxin, anatoxin A, cylindrospermopsin, and microcystin in those water bodies. And so given the taxa we see in Upper Klamath Lake, I am hoping to expand some of the toxin sampling in Upper Klamath Lake this summer. You know, currently Upper Klamath Lake's really only assessed for microcystin. And so thinking about the way the water is all connected in the basin and the fact that we have, you know, all 4 of those common toxins in the refuges, you know, made me a little suspicious that we might see that in Upper Klamath Lake as well. So just wanted to alert folks that that is potentially in the works. You know, I'm couching it at this point as a synoptic study, just because I'm uncertain what we'll find in terms of those other 3 toxins. We know that we get very, very high hits on microcystin, but you know, there's been inconsistent and spotty monitoring of those other toxins in the past. But, you know, we've really seen an exacerbation of the cyano blooms in Upper Klamath Lake in the last, you know, 5 years in particular. So anyways, just wanted to share that information for folks that there may be more data coming out of Upper Klamath Lake soon.
Yeah, Megan, you'll want to be very aware there and cognizant that that you can get a lot of those toxins from benthic cyanobacteria, and not necessarily from planktonic. So it's sounding to me that you probably have benthic sources there to get that range of toxins, because in Upper Klamath Lake, it's known that the AFA is not toxic. We've got the genome sequence for the anabina that comes up early. That's not, or the dolichospermum, that's not toxic. So you just really think about that and try to be as aware as you can of the source that you're testing for when you're sampling down in the refuge.
Sure, yeah, and we do. We also are having Tim Otten do taxa assessment for us in the refuge, and you know, we have seen in the refuge complex, I should say, and we have seen taxa down there that aren't necessarily benthic that are capable of producing those toxins. So
okay, good.
I wonder if
Tim will know about that.
Yeah,
all right.
Exactly. Yeah. I know that you guys have worked together in the past extensively. So anyways, you know, we'll continue with the taxa analysis with Tim as well. You know, just so that we have that information for the, you know, specific location of the sample of the sample collection. Yeah. But thanks, Theo. That's good.
Good. Thank you, Megan. Let's move.
Yeah, Theo.
Thank you, Rebecca. Can you stop?
Sorry, Theo.
What's that?
Can I was just going to say, in Malheur Reservoir, we saw the highest anatoxin A we've ever seen in Oregon, and it was almost 9 parts per billion. And again, that came in over time and temperature. So, you know, Kaylee was saying that it would have been even higher had it been, you know, within the criteria. So a little bit scary.
Something to pay attention to for sure. Yeah. Thanks very much, Rebecca. Can you stop? Oh, yeah, there you go. Our next speaker is Greg Baird, also from Oregon Health Authority, and he'll speak on cyanotoxin monitoring requirements for public water supply systems in the state. Go ahead and share your screen and take it away, Greg.
All right, thanks, Theo. Let's see here. How's that look? Does that look like the right slide?
Yep, you're ready to go.
Right.
Thank you.
Great. I think I'll just turn off my video while I'm presenting. Well, okay. Let's see. Okay. So thanks for having me, Theo. My name is Greg Baird. I'm the Emerging Contaminant Specialist for the Oregon Health Authority Drinking Water Program. Today I'm going to talk about our cyanotoxin monitoring requirements for public water systems in Oregon. And here's an overview of the presentation today. Just briefly touch on the history of cyanotoxin monitoring by public water systems, leading up to us adopting a regulation. We'll talk about the actual regulations, what the rules require for public water systems, some other related monitoring being done in relation to cyanotoxins, and also some potential rule revisions that we are thinking about this year, and then resources on our website. So as most of you probably know, there is not a federal national primary drinking water standard for cyanotoxins in drinking water. There are non-regulatory, non-enforceable health advisory levels. However, for 2 cyanotoxins, total microcystins and cylindrospermopsin. Also at the federal level, in regards to cyanotoxins, there was a requirement to monitor for certain cyanotoxins during the 4th unregulated contaminant monitoring rule that happened between 2018 and 2020. So, but other than that, in the absence of federal regulations, some states that have HABs issues affecting public water systems are adopting their own regulations, including Oregon. So here are the drinking water health advisory levels in Oregon. These were the levels established by EPA for total microcystins and cylindrospermopsin at 2 different levels. A lower level for vulnerable populations, which is defined as infants, especially formula-fed infants, children younger than 6, people with pre-existing liver conditions or receiving dialysis, and pregnant women and nursing mothers, and then a higher level for everybody. So in Oregon, since we adopted these into regulation, they are regulatory and enforceable. A little bit of history about how we got to having a regulation in Oregon. Our cyanotoxin monitoring with public water systems started around 2008. We would recommend that a water system that had a bloom in their source do testing. 2011, we had some money that we could pay for the testing. 2012, we followed the best management practices based on EPA guidance, where water suppliers downstream of a recreational advisory would sample voluntarily. And then up until 2018, we used the EPA health advisory levels and the EPA guidance. We had some detections in raw water, but never in treated water. And then that all changed in May 2018 with the Salem advisory for vulnerable populations. So at that point, we adopted regulations with a temporary rule in place for the last half of 2018, and then a permanent rule adopted January 2019. So getting into what the rule requires, it requires public water systems with susceptible sources to monitor for cyanotoxins. And this is the definition of what a susceptible source is. So there's about 60 sources, water sources at 59 public water systems that meet this criteria and are required to monitor. It's basically having a past documented bloom or a cyanotoxin detected in the source, or they're downstream of a source that had a HAB or cyanotoxin detection, or they are the sources on the 303D list for algae and aquatic weeds. This is what the list looks like. It's posted on our website. I'll provide a link to our website at the end of the presentation where you can see this. It has columns on the right where you can see where each particular source, which criteria that they met to be put on the list, and some sources met a couple of the criteria. I actually updated this list a few days ago, so it's updated March 8th. There weren't any sources added or removed from the list, just some sources that weren't previously on the 303D list that were added to it. So this is a diagram with showing the basic, the primary sampling locations that take place under this rule. Primarily, routine monitoring is done at the source, shown with the SRC code here on the diagram. This is where all the water systems with susceptible sources sample. They also some of them might also sample at the common header instead, the CH on the diagram. If they have multiple sources that combine before entering the treatment plant, then we have them monitor at the common header, because we want to characterize the water that's actually entering the treatment plant. In the event of a detection over a trigger level in the source or the common header, we would require entry point or finished water sampling. So that's fully treated water entering the distribution system and going out to customers. And then if finished water is confirmed over the health advisory level, sampling would take place in the distribution system in order to lift the advisory. So those are the kind of 4 monitoring locations, standard monitoring locations. These are the actual monitoring requirements. Like I said, all of the systems do raw water monitoring every 2 weeks for total microsystems and cylinders for mopsin between May and October. Then it kind of steps up. It's kind of logical. If there's detections or a recreational advisory upstream, then the raw water monitoring goes to weekly. If the raw water is above this, at or above this 0.3 trigger level, we call it, the finished water monitoring begins and continues on a weekly schedule. Then if toxins are detected in the finished water goes to daily. If they're detected over the health advisory level in the finished water, we do a confirmation sample as soon as possible. And then if that confirmation sample is also over the health advisory level, advisory needs to be issued. We're also going back to that third bullet, that 0.3 trigger level. We may ask water systems to voluntarily do raw finished weekly monitoring if the raw water detections are greater than or equal to 0.15 micrograms per liter, depending on lab capacity. And that's because we now have a analysis method that can report out, report with a minimum reporting level that's much lower than we've had in the past. So, and I'll talk about that in a second, a little bit more. Here's a flow chart diagram that's posted on our website that kind of summarizes those monitoring requirements I just talked about, which is pretty handy. It kind of helps public water systems figure out what monitoring is required if there are detections, etc. Purchasing water systems. So water systems that don't have their own surface water source, but buy water from a water system that uses surface water, they do not have any routine monitoring requirements. They would only monitor if the seller was the seller had finished water detections confirmed over a health advisory level. Purchasers would need to monitor in order to come off the advisory. So here's some reporting timelines for sellers to notify their purchasers of finished water results here. So the public notification or advisory, like I said, is required if there's finished water confirmed over a health advisory level. It applies to the public water system and any purchasers. Do a press release. And in order to lift the advisory, they need to have 2 daily finished water samples at or below the health advisory level, and the distribution samples at or below the health advisory level for 2 days. And entry point and distribution detections have to be included in community water systems annual consumer confidence reports, which are reports that are required to be sent to their customers every year. Reporting of results. The rule has certain timelines for reporting results. Results over health advisory levels, finished water results, confirmation samples have to be reported a little quicker. Results used to lift an advisory, etc. So. Analytical methods. Our rules require the ORLAP accredited lab or the DEQ lab be used for the analysis. For total microsystems, we require EPA method 546, which is the ELISA method, since that's the only approved method that measures total microsystems. For cylindrospermopsin, there isn't an EPA ELISA method, so DEQ developed an ELISA method, and that's the method that we require, except for if cylindrospermopsin is detected at the entry point above the health advisory level, so in the finished water. With the ELISA method, the confirmation sample needs to be analyzed with EPA method 545, which is the LCMSMS method. And like I mentioned before, DEQ lab began using a more sensitive ELISA test kit in 2020 that allows for a lower reporting limit for total microsystems of, I think it's 0.08 micrograms per liter instead of 0.3. So I think this kit's called the SAES kit, and it is considered equivalent to the kit mentioned in EPA method 546 and is allowed to be used. So we want to get the word out about that. I'd say we encourage using the SAES kit due to the ability to get those lower minimum reporting limits. All right, so this is hot off the press. This is, you heard it here first. Here, we're thinking about doing some potential revisions to the rule. And we're in the very early stages of this. So there's time for feedback for sure. And of course, we'll have hearings and all of that stuff. But here's some of the high points. We're considering lowering that trigger level for total microsystems from what it is currently at 0.3 to 0.15, based on that SAES kit that can give us lower reporting limits. Right now, the lower health advisory level for total microsystems is 0.3. So having the reporting limit also be 0.3 doesn't give you much time to react. If you have a reporting limit of 0.3, your raw water coming into your treatment plant is, right at the health advisory level already. So we're thinking about requiring that weekly raw and finished water samples be paired, so collected at the same time and at least 7 days apart. Right now, that's kind of been the practice, but it's not explicit in the rule. We want to add language about that SAES kit being equivalent to the standard kit in method 546. We'd like to require some faster reporting of finished water entry point results taken in response to a raw water result over the trigger level. Right now, results that are non-detect don't have to be reported until 10 days after the end of the month, and we kind of want to know what those finished water results are quicker than that, even if they're non-detect. So that's why we're bringing that up. And then requiring samples that are collected outside of the May to October monitoring season that otherwise meet the rules, requiring that those be reported. So if there's any immediate feedback on this, let me know. I'd like to hear it. Other related monitoring, we're doing a qPCR study, monitoring raw water going into treatment plants for genes. In 2020, all the water systems did it. In 2021, there was we fine-tuned it down to water systems that were within the wildfire zone or sub-watershed impacted by fire or had a cyanotoxin detected in 2020. So we're still, all the samples have been analyzed, but I think the data is being reviewed right now. We also have a voluntary cyanotoxin monitoring program for systems that don't have a source on the susceptible list. They can contact us. We can arrange for cyanotoxin monitoring to help them out. All of these cyanotoxins samples results since July 2018 are posted on our website at this address up at the top. So those, if anyone's interested, you can go there and see, sort by detections and or look at particular water systems. So summarizing what we've been seeing since the rule went into effect in 2018 statewide so far, annually we have around 20 to 60 detections for total microsystems in the raw water, and much less cylindrospermopsin detections in the raw water. Mostly at one water system, Gates, on the North San Em, one time at Josephine County Park's Lake Selmac 2. And there's about 6 water bodies of concern, of most concern, I'd say. No finished water entry point detections, thankfully, since the rule went into effect, so that's good. A summary of last year's monitoring results, kind of echoing what Rebecca said earlier. I would say it was a quiet season. I was bracing for a busy season after the wildfires in 2020. Was worried about increased nutrient runoff, maybe causing increased blooms. We didn't really see that, I don't think. At least not in 2021. So we had microsystems detections in raw water, 8 systems listed here. Of those 8, 6 of them, those raw water detections were at or above that 0.3 trigger level, so they increased their frequency of raw water monitoring and began finished water monitoring. But again, there were no finished water cyanotoxin detections, thankfully. And we had a cylindrospermopsin detection at one water system, Gates. Notable maybe about the microsystems detections, Cottage Grove, Cresswell, and Newport. 2021 was the first year that we had raw water detections there, so I'm not sure what to attribute that to. Could be the lower minimum reporting level. Here is the link to our drinking water cyanotoxins webpage, where we have more information about the rule, the list of susceptible systems, the flow chart that I showed, the fact sheet, some FAQs for advisories for the different populations, and also in the treatment information section there, we have the first document that's optimizing toxin removal, which we provide for the public water systems to give them some ideas about how they can modify their treatment or optimize their treatment to improve for cell or toxin removal. Yeah, so that's it. Here's my contact information. And if you have any questions, let me know.
Thank you, Greg. Very good, very comprehensive. We have about 2 or 3 minutes for questions. City of Gates, is that in the Santiam Canyon?
Yeah, it's the first public water system downstream from Detroit Lake.
Okay, yeah.
Mm-hmm.
Any questions from anybody?
Hi, my name is Janet. Can you hear me?
Yes, go ahead.
Hi, I'm with a tribe in coastal Oregon, and we're trying to set up our environmental testing lab for things like cyanotoxins. But I saw on one of your slides you were talking about qPCR for some of the genes. Can you tell me more about what you're doing?
Yeah, there's a couple of projects going on with qPCR by different groups, and some on the same water bodies, but in particular, we used our grant for collecting samples at the raw water intakes going into treatment plants and testing for microsystems, producing genes, cylindro, and saxitoxin, I think. And basically, we were investigating whether we could make a correlation between the presence of genes and the presence of toxins, and see if maybe we could detect genes before the toxins showed up, with the hope of there maybe being a correlation and that qPCR could be a cheaper alternative to actual toxins testing, as far as having a heads up. So that was kind of our project.
And did you find any correlation?
Maybe Aaron could talk about this more, but I think we've only had a chance to look at the 2020 results so far, and I would say that there wasn't a clear correlation. And 2020 was also a quiet year for toxins, so that made it a little difficult.
Check the, Aaron, yeah, go ahead.
Yeah, just going to jump in. I would encourage you to stick around for Kaylee Clausen's presentation later today at 3:40. He's going to talk a little bit about some of the qPCR information that we've collected. And Greg spoke correctly that thus far we haven't seen any real strong correlations, but we're still doing analysis. So I would say the verdict is still too soon to say, because we have more data that we analyzed recently that we hope to look at more closely soon.
Thanks, Aaron. Just before we move on, one question posted from Nadia Gillette. Does OHA or DEQ plan to publish a list of toxin-producing species or genera based on reliable and recent data? Greg, are you still there?
Yeah, I think that's one for Rebecca, or I think we have a list somewhere, right, Aaron? Or Rebecca?
I think we have a generally known list of potentially toxin-producing species. The question is where and when, and how often. So I think there's, I know we've been collecting a lot of microscopy photographs of different species and different water bodies. And I think one of the things to do is to have a more complete inventory of all the species and when the toxins are being produced, so we kind of can link those species to the toxin production in different water bodies around the state, and something about the timing of those species as well.
Yes,
so there's probably more work to be done
at time, so we should keep that up.
Yep.
Thank you, Aaron. Let's move on then. Greg, can you give up your screen sharing, please? Good. Okay, and I'd next like to introduce Rochelle Labiosa, and I am, what's happened here? I am displaying Rochelle's slides from my computer here. I'll just get that up.
Hi, Theo, can you hear me?
Yes, Rochelle. So Rochelle is from EPA in Region 10 in Seattle, and she will be talking about the EPA and support for CyanoHABs. Go ahead, Rochelle, and just tell me when to advance the slides.
Thanks, Thea, and thanks for advancing the slides. I had some technical issues that kicked me off the presentation, and then I recently rejoined, so hopefully those won't continue. So I'm Rochelle Labiosa. I'm the HABs coordinator for EP Region 10 in Seattle. We cover Alaska, Idaho, Oregon, and Washington. And I wanted to thank you all for including me today. It's important for me to hear or learn from you all about your needs around HABs. So I hope to have some discussion after my slides. Next slide, please, Thea. So I have to provide a disclaimer that the views expressed here are mine and not necessarily those of the EPA, and that mention of products or services does not constitute an endorsement. Okay, next slide, please. So in this presentation, I'm going to provide a lot of background information that I'm going to move through rather quickly. So I'm going to focus mostly on new stuff, but I want to give an overview of EPA's work around HABs. We have a multidisciplinary approach, which includes a lot of folks with different expertise, and we all work together to address HABs since it's such a complex issue. And our focus is on providing or producing guidance and technical support, working on regulations, doing assessments of waters, working on partnerships and leveraging resources, conducting outreach, and conducting research and development. Next slide, please. Yeah, oh, there we go. We have a lot of statutes that basically determine the work that we do. One of our main statutes that provides our regulatory and statutory authority is through the Harmful Algal Bloom and Hypoxia Research and Control Amendments Act. The amendment, it was amended in 2019, and this determines the role that EPA plays, and our EPA role is mainly on freshwater events. So our response role is on freshwater, and NOAA responds on marine events. And then it describes our process for stakeholder engagement, and we co-coordinate an interagency research agenda, which includes a lot of other federal agencies, as you see here. Next slide, please. For our other statutory authorities, we have authority under Drinking Water Protection Act that was in August 2015. And through that work, we created a strategic plan, which was also published in 2015, There's other work that we do under, for example, the CIDWA for the contaminant candidate list. We've included cyanotoxins in CCLs 1, 2, 3, and 4, and some in the draft CCL 5. We also just completed the unregulated contaminant monitoring Rule 4 work together with drinking water programs across the country. And there is a summary report that was published in January 2022, which identifies what the results of that, the UCMR4 are. And we monitored in the UCMR4 several different toxins, so about, I think, 10 cyanotoxins in UCMR4. And then in this work, we've also developed health advisory levels for microsystems and cylindrospermopsin for drinking water, which others have mentioned already on the call. Next slide, please. Our other statutory authorities come through via the Clean Water Act, and this is on protection and restoration of the nation's surface waters. One of the main connections is through regulation of excess nitrogen and phosphorus pollution. That's a key area to mitigate HABs issues. And we work also on producing guidance, such as these recommended human health, recreational, ambient water quality criteria swimming advisories that were published in May 2019. And those advisories are used by states which have, states and authorized tribes which have primacy for the water quality standards program. So we produce the guidance, and then states may choose to adopt those into their regulations if they, and EPA plays an oversight, technical support and oversight role for the standards program, for example. Okay, next slide, please. So this is just a summary of some important guidance that I've mentioned. The drinking water health advisories, which were published in June 2015. Again, we have these for only microsystems and cylindrospermopsin so far. Those are the two toxins we had sufficient data for back in 2015. And we have these are 10-day advisories. We have magnitudes of 0.3 micrograms per liter for microsystems and 0.7 micrograms per liter for cylindrospermopsin for less than school-age children, so bottle-fed infants and preschool children. And then for school-age children and adults, microsystems of 1.6 micrograms per liter and cylindrospermopsin of 3 micrograms per liter. And then for the recommended recreational ambient water quality criteria and swimming advisories, the magnitudes are 8 micrograms per liter for microsystems and 15 micrograms per liter for the cylindrospermopsin. And as swimming advisories, these are not to exceed values. Okay, next slide, please. We also do ambient water assessment through our National Aquatic Resource Surveys that we do jointly with participating states. And this year will be the National Lakes Assessment that will occur in 2022. The different assessments for different types of waters are roughly every 5 years. They will include some cyanotoxins and indicators of blooms. And these are nationally consistent studies, just a snapshot in time that take place typically during the summer period. Okay, next slide, please. Yeah, I'm not sure. Oh, there it goes. I wanted to highlight another body of work related to the standards, which is our EPA recently published updated recommended criteria to address nutrient pollution in lakes and reservoirs. So this is new as of 2021. The new approach is a stressor response-based approach. And it's they're model-based. So basically you have to set up the model a certain way, and then you get some outputs from that model, which are online via Shiny apps. There are hypoxia, microsystems, and zooplankton submodels that can be used to derive chlorophyll A criteria values. And those in turn are used to derive total nitrogen and total phosphorus criteria for lakes. And there'll be a webinar on these criteria on March 29th at 11 a.m. I've included the registration link so you can get to that when Theo sends out the slides. So as you can see here, the human health endpoints are via microsystems only, but we have the ability to set it up for both drinking water source values as well as recreation. So there's a slider where you can pick your value that you want to target for developing those criteria. So these are recommendations to states, for example, if in case they want to include these in their water quality standards to protect their waters. Okay, next slide. We've also published a suite of other technical support resources. I have them as a one-stop shop here, all listed out. I won't go through each one, but a lot of these were developed, again, after the strategic plan was published in 2015. A lot around management tools for public water systems, and then also for recreational waters. More recently in 2019, we published a final technical support document for the Cyanotoxin swimming advisories and recreational water quality criteria in 2021. So that's new since I last presented. And then you can get to those documents through the EPA cyanobacteria and cyanotoxins and recreational waters webpage. Next slide, please. In addition, there are videos, tutorials. We have a lot of outreach through our Freshwater HABs newsletter and webinars. I believe Rebecca in the chat or maybe online mentioned our upcoming fish and shellfish webinar, which I have a link to later in these slides. So a lot of work going on to provide outreach on the latest science and technical advice or recommendations. We have new here is the federal funding for prevention, monitoring, and treatment of HABs. We have a workshop summary. So we conducted a workshop last year and then produced a summary. This was jointly with several different federal agencies. So if you're interested in federal funding for HABs, then I recommend checking out the summary. Next slide, please. One thing I wanted to highlight this year, last year was a pretty tough year. We had a lot of events around the region and many illnesses and dog deaths that were putatively linked to HABs or cyanotoxins. We didn't often have confirmatory analyses of those events, but just given the circumstances, that was one of the general conclusions for some of these issues. And so I wanted to make another push on prevention of dog illnesses and deaths. We have a Protect Your Pooch website where we talk about what to do if you suspect your dog has been exposed to cyanotoxins, including to rinse them off immediately, wearing gloves, watch for symptoms, and quickly take them to the vet. In certain instances, we've seen that pet deaths can happen quickly depending on the concentrations level of exposure, but it can be minutes to hours after recreational exposure. So we encourage outreach to vets, and here's a CDC card on vets specific to HABs and pets exposures, and we also have a video to share. Okay, next slide. Another new EPA tool is a HABs story map with an advisories time series. I have the link here to the story map, which may be helpful for providing background information for programs. And here we show the time series of advisories. We started here in 2015 and have shown the increase in advisories through time. We believe much of this may be due to an increased awareness, but we haven't parsed it out since these are responsive advisories pretty much across the nation. So when someone sees a bloom, they report it to their agency, and agency goes out and monitors for that bloom. So more in a surveillance mode. Next slide, please. We also have a website which summarizes all of the different research going on around HABs, and I've provided links here. We've done a lot around monitoring remote sensing. I think a few folks may have mentioned cyan, and that's included under the remote sensing topic. Toxicology of cyanobacteria, ecology of HABs, epidemiology and health effects, and harmful algal blooms in drinking water treatment. Next slide, please. In Region 10 specifically, we've worked a lot on development of the Cyanobacteria Assessment Network Project, or CYAN, which is a remote sensing tool we've conducted or developed jointly with USGS, NASA, and NOAA. And here are some example results from Klamath. You can see this time series. I know it's hard to read at the bottom, but we've turned the data into a web app. So it's now accessible through a point-and-click web app interface that you can access from your desktop. And here are, again, results from Klamath. So you can just drop a pin and click on a lake of interest, and then you can find a time series information. You can look at the imagery and download it just very seamlessly. And you can get access to that desktop app through the website. And we've worked jointly with ODQ on some of this development for the web app. So it's been a great partnership there. Okay, next slide, please. We've also been working on a qPCR project. Several folks mentioned molecular tools like qPCR, and our focus of our project is to see if the quantitation of cyanotoxin producing genes can provide early warning for bloom development and for cyanotoxins being above certain thresholds. So we've been conducting some work with partners on this to collect samples from Detroit Lake, Oregon, North Fork Reservoir, Oregon, Anderson Lake, Washington, Spanaway Lake, Washington, and Pass Lake, Washington. So several waters around the Northwest. And we're also looking to compare that to some of the satellite data results to see if we see relationships. Right now, we think we can see about a week or two of advanced warning depending on the organism and toxins. So, but we're continuing to work on those data, and we'll be summarizing the results shortly. Next slide, please. I wanted to highlight some of our planned work coming up from 2022 to 2023. We're developing an EPA internal strategic plan. This work is in response to an OIG report that was published. It was an audit of EPA's HABs program. And so as a result, we're developing this internal strategic plan. So it's important for us to know the challenges that you all face on HABs to better respond to that via the plan development. We're working on the HABs and hypoxia events of national significance policy finalization. I mentioned that, I think, last year that we were working on that, and it had been published for comment at that time. Now we're working on finalizing that policy. Another area of focus is on Cyanotoxin A toxicological studies. As you know, we have guidance values and HALs and recommended swimming advisories only for microcystins and cylindrospermopsin. We have published health effects support documents for microcystin cylindro and for Cyanotoxin A. And in the past, we looked at the data to see if we could develop the criteria recommendations or HALs for Cyanotoxin, and we looked at this in 2018, for example, and didn't have enough data. We're continuing to look at that data again, look at the literature, and also pursue our own toxicological studies to see if we can develop the data to develop how, for example, HALs or criteria. So over the next year, those toxicological studies will be completed, hopefully. You never know with research studies, but that's our target. We're also working on developing a draft saxitoxins health effects support document. We're continuing our prior Region 10 research projects, so hopefully the some reports and publications will be forthcoming from that work. And then we have submitted an internal proposal to produce research on the best practices for benthic HABs monitoring and assessment. So that's another set of new work we'll hopefully be conducting. Next slide. Okay, one major event, I guess, is the bipartisan infrastructure law funding allocated to EPA. It's the single largest investment in water that the federal government has ever made, or approximately $50 billion in infrastructure funding for water. And so we think this will make a major change for water programs across the country and encourage our states to think carefully about their priorities. And we've actually just issued a new memo outlining a strategy to equitably deliver clean water through the infrastructure law. So this is exciting news for everyone in water. Next slide. We have some upcoming webinars that could be of interest. On March 16th, the Water Sensors Toolbox webpage webinar with some case studies for drinking water and cyanotoxins. Next slide, please. Also, the Fish and Shellfish webinar, I just have a link here, but there are a lot of great speakers lined up for our workshop on March 22nd. Next slide, please. Okay, and very quickly, I'll go through a recap of 2021 and moving toward 2022. So overall for 2021, it was quite a busy season across the region, although quieter in Oregon, I would say, in terms of advisories issued. So across the Northwest, the 3 states that have surveillance programs, Alaska does not have a program, but Idaho, Oregon, and Washington do. We had 71 advisories. One was a drinking water or do not drink advisory for a very short period of time in Idaho. And there were 70 water advisories, and we counted about 150 detections of cyanotoxins in waters across the region. There are many high-profile issues, including very high cyanotoxin concentrations in the milligrams per liter in Pass Lake, Washington, and in Anderson Lake, Washington, for example. There was an event in the Tri-Cities in the Columbia River in Washington, where We think it may have been linked to a benthic bloom based on the organisms identified in that case, but Anotoxin A concentrations or detections were identified at the intakes for several drinking water plants in the Tri-Cities, and there were also several dog deaths and illnesses linked to the event. So it was quite impactful. Unfortunately, I know do not drink advisory was not issued, so all the concentrations were below the state's guidance value for finished water, but there was breakthrough into finished water below their guidance value for anatoxin. So it was quite impactful. Next slide, please. So I wanted to just say about benthic HABs, they're an emerging concern in the Pacific Northwest. So their EPA has not yet developed monitoring guidance or risk communication tools for benthics. Multiple toxins may be present, and there are states who have developed their own recommendations. This is just an example for risk communication from California to check for benthic algae before recreating. They also have a frequently asked questions. And ITRC has an identification video that they've published here that includes some images of benthics. And then we have jointly with the Army Corps published a workshop results for benthic research and monitoring priorities in 2021. So I have the link here on benthics. Next slide. So our 2022 message, very similar to 2021, is please be prepared. We're updating our freshwater internal HABs response plan. We have a tool that kind of collects together all of our tools for before, during, and after an event in the CPRT, or the Cyanotoxins Preparedness and Response Toolkit. So this is a great one-stop shop to get you started. And next slide. And again, please be prepared early. This is a recent image from the drought monitor on the drought conditions that we're still facing in Eastern Washington, across Oregon, for example, very severe drought conditions, unfortunately. So although it seemed like kind of a quiet year in Oregon last year, please keep your eye out, and especially for benthics. And next slide, thank you. I don't know if there's time for questions.
Okay, sorry, it took me a minute to unmute. No, we do have to go ahead. But thanks so much, Rochelle. That's action-packed. You have lots of links there. So as Rochelle mentioned, we'll post this this slide set together with the others, and there's so much information there that's really important and really good and very accessible. So thank you, Rochelle. We'll probably have time after 11:20, Rochelle, for questions, but let's at the moment continue. Our next speaker is Al Johnson from the Forest Service, and he'll talk about Forest Service HAB monitoring. Go ahead and share your screen, Al.
All right, hold on just a minute.
You're not on full screen mode yet, Al. I think back where you were, you could have done it at the bottom right-hand corner. The bottom right hand, next to the slider for the Zoom. No, bottom right. Oh, yeah, that one.
Okay.
There you go.
How's that?
Good. That's good. Thanks.
Okay. So what I'd like to present is just a kind of a brief overview of what the Forest Service did for HAB monitoring in 2021, and a little bit about Forest Service policy and direction, and some other related activities that the Forest Service is doing. So for Oregon and Washington, the the Forest Service focuses on high-use recreation sites, basically developed recreation sites where a fee is charged. There's just way too many water bodies for the Forest Service to monitor all of them. So, so the Forest Service generally does not monitor lakes and wilderness areas or other remote areas. That on those lakes that have a history of HABs, the Forest Service posts educational posters at public access points and keeps those up through the entire recreation season. And when surveillance monitoring occurs, then, and there's a sign that a toxic bloom may be present, a Forest Service caution sign is posted in many cases. And in some cases, samples are collected for cyanotoxin analysis, and those are shared with OHA and other health authorities. At the beginning of the pandemic, the Forest Service closed all of the developed recreation sites for most of the recreational season, and so little monitoring was done then. However, in 2021, the recreation sites are open. However, it was left up to the local managers whether or not they would do any monitoring of HABs throughout the recreation season. And so in some cases, caution sign was just put up at the beginning of the recreation season, and it was left up for the entire season. I just wanted to give some credit to partner agencies with the Forest Service. It's, we get help from, like DEQ. A couple examples are Crescent Lake, Odell Lake. eWeb monitors reservoirs up the McKenzie River, and we rely a lot on information from the City of Salem's monitoring of Detroit Reservoir, and the Corps of Engineers and Geological Survey also at times provides information to the Forest Service. So the two signs here, the blooms in Oregon waters and the dog safety poster, those are provided by the Oregon Health Authority. So we put these up in developed recreation sites that have a history of blooms. And one thing I'll say about the blooms in Oregon poster on the left is I heard a lot of complaints from recreation managers from forests across Oregon that it's a big job to put these signs up every year and maintain them. So in 2021, I had metal signs made, and so now we're replacing the older paper laminated ones with metal signs in many recreation sites. And then the caution sign on the right is put up in many situations where either a potentially toxic bloom is suspected, or the local managers have decided not to monitor the lake. However, that can create some miscommunication with the public, as happened last July at Settle Lake on the east side of the Cascades, where people saw the sign and thought that there was a toxic bloom present, but that wasn't the case. The local managers had decided to put up the caution signs just because Settle Lake has a history of HABs. And so that created some panic in the mind of a lot of people. So getting the right message out to people, and so they're aware but not overly concerned, has been an issue. When a health advisory is issued, just to get people to pay attention to the signs and read the information that's posted on bulletin boards, we oftentimes do put up notices at access points that hopefully get people's attention, so they will look at the detailed information that's posted. This is a summary of the Forest Service cyanotoxin analysis for 2021. All of the samples came back non-detect. There was only a limited sampling done in 2021. Part of that was due to just a delay in getting a new contract in place with the lab. Forest Service in Oregon uses Greenwater Laboratories for cyanotoxin analysis. So there was, that caused a bit of a delay and probably reduced sampling. As others have pointed out, it was a pretty mild year in terms of severe cyano blooms. Most lakes stayed pretty clear through most of the summer. Diamond and Lamolo did show some fairly dense blooms in August, but overall not too bad. There's been some speculation that maybe the wildfire smoke maybe had a influence on the severity of the cyano blooms, and there may be some effect there, but that's kind of speculative right now. There was a study done on Castle Lake in Northern California that was covered with smoke for 55 days, and there they concluded that the wildfire smoke influences light regimes, heat content, and primary production. So perhaps there's an effect, but in the surface waters, they found that wildfire smoke reduces UVB radiation on the surface, and also photosynthetically active radiation to some degree. So perhaps that contributed to a lower intensity of blooms in 2021, but we don't have any data to conclude that. So another thing that the Forest Service has been working on for about a year and a half now is through our Geospatial Technology and Application Center. They have been doing some work on detection of blooms with remote sensing. And so their focus has been on water bodies greater than 1.5 acres. And they've been trying to look back at historic records to determine trends and provide a relative measure of HABs and provide information to lake managers every 5 days. So here you see some work they did looking at Odell Lake in the upper part of the photos, and then Crescent Lake in the lower part. So they use variety of remote sensing data sources and examine lakes for which we have toxin monitoring data and also look across the board for different concentrations of algae. So one of the primary reasons why I have been looking at this data is I wanted to get a better sense of what the spatial extent of CyanoHABs is for both Oregon and Washington, but particularly in Washington, because for Forest Service lakes in Washington, we did not have much information. So I'm at this point, using this data to see, is the Forest Service missing something? Are there lakes with developed recreation sites that we should be monitoring? So that's kind of one of my primary focus at this point.
Al, could you wind up in a couple of minutes, please?
Okay, this is just an example of current output from that project right now. You can actually zoom in on lakes and get more information, but we're really just kind of evaluating this right now and looking at it for potential applications. So that's all I have. So if there's time for questions, I'll take questions.
Thank you, Al. We better hold them until the end. Thanks very much. If you could release your screen, please. Yeah, we'll go right through the talks because we're running a bit behind now, but we'll have time between 11:30 and 12. Our next speaker is Tina Lundell from the Army Corps of Engineers, and she'll talk about the Corps HAB monitoring and research. Tina.
Yeah, hi everybody. Can you hear me okay?
That's fine. Yep, that looks really good. Thanks.
Good. Yeah, this is I included a photo here of Willow Creek Reservoir because they get really bad blooms every summer. And so you can see this one near the dam. That boat in the corner shows the perspective, of how big that bloom is. So that's kind of our ongoing problem child out there. And then the water quality team from the Portland District Office, we go out and collect samples when we have the time and the funds. And in 2021, we were at the Willamette Valley and collected samples for a couple of reservoirs. And one of them, for example, was Fern Ridge because OHA reported a dog death that could have been linked to a bloom at Fern Ridge. So on July 13th, we went down there and we collected a sample at Sunwalt Park and Fern Shore RV Park. Then we sent the sample to the Greenwater lab, and their results showed that the species of cyanobacteria present was Deliciospermum and Aphanizomenon, but there weren't any detectable cyanotoxins present. But, during that time, we kind of monitor and look at the emails we get from DEQ for the satellite images, and the cyanobacteria levels, they were really high at like over 970,000. And that's a 7-day average daily maximum cells per milliliter. And the WHO guidelines is 100,000, so that was super high. So we were kind of watching that, and it stayed over 400,000 through October. But the conditions at Fern Ridge kind of remained the same. It was a very turbid lake, but yeah, it didn't seem to be getting worse there. So we didn't sample there again that summer. And then we got a report from our Corps park ranger that the Dexter Reservoir, they were experiencing a big cyanobacteria bloom. So mid-July and late August, we went down there and we collected samples at the Lowell boat ramp. And that also came back from Greenwater with the same cyanobacteria species as Fern Ridge, except in the August sample, it also had Gliotrichia. But again, there was no cyanotoxins at the detectable amounts above the MRL. So there was no advisories posted on those. And then also we've The Corps has contracted University of Idaho for several years at Willow Creek Reservoir. And so Frank Wilhelm there, he collected some samples starting in early June. And I mean, like I mentioned before, that reservoir is notorious for getting blooms. So it's pretty much expected that you're going to get a bloom there. So he collected samples in early June, mid-July and August, and also late September from that northwest corner. And we got hits on the cyanobacteria species present, again, was Delicious spermum and Glialtrichia in July. And then the September sample had Microcystis, and that's a pretty common species that appears later in the summer or in the fall there. And that's the only one that had a hit on the cyanotoxin microcystin, but it was at 3.44 nanograms per milliliter, which is way below the 8 parts per billion for the recreational guidelines. So again, there was no advisory posted for that. And then just want to tell everybody that, yeah, we do let OHA know when we collect samples and also, what the results are. So we keep them in the loop, and then they post an advisory, if needed, but we don't put up any signage for an advisory. We just have the core signage that we keep up, all year for educational purposes. And I didn't include it in my slideshow, but if I have time, I'll show you on my desktop what that signage looks like. And so, so we didn't have any advisories this past year, but I always want to say that can be misleading. Doesn't mean you don't have toxins out there. We just weren't out there at the time to collect any samples that might have had toxins. So it's not hopefully the lakes were all below the toxin advisories, but that's what we did collect for that summer. And also, there's a significant cooperative effort between USGS, us, the Corps, eWeb, and City of Salem to utilize the vertical profiling stations. And they were installed in early 2020 at Cougar and Detroit reservoirs. And the Cougar buoy platform, that was removed last summer, and then that's going to be deployed this spring at Blue River Reservoir for various reasons. For one thing, we need more data. The one at Cougar, for different reasons, I think they got about 5 months of data. Kurt could correct me if I'm wrong, but I think they got about 5 months of data because there's some transmission issues with the real-time data reporting. So I'd like to get a larger data set than that and then compare that with the data set at Detroit. So we're hoping to have better luck this coming year. And also that Blue River Reservoir, eWeb, they found Slendrospermopsin present in that reservoir in the past, although last summer it was below the detected MRL limits. So it should be an interesting reservoir to have that equipment in to do some monitoring. The sensors that we include in these multi-parameter data sondes include temperature, conductivity, DO, turbidity, pH, total chlorophyll, and FDOM, the fluorescent dissolved organic matter. So with all these sensors, we're getting a pretty good picture of what's going on. So this study could really provide an invaluable look at when these blooms develop, how they progress through the season, and then when they tend to concentrate in the water columns on a daily and seasonal basis. And also how other water quality parameters might be used to forecast pending bloom conditions. So this is a really cool study. So it's going to be interesting, to see what kind of data they get from this. And also, I don't have it on my slide, but I should mention that in cooperation with USGS, there's some post-wildfire studies being conducted, and that's upstream of Detroit, Cougar, and Blue River reservoirs. And doing that monitoring, USGS, they're doing temperature, DO, pH, turbidity, and then also collecting nutrient samples. And then we're providing the funding for CCAL at OSU. They're doing the analysis of those samples. So this study, it's ongoing. And like I said, Blue River is going to be the primary focus this year, upstream of Blue River. So it's going to be interesting to see the impacts from the wildfires, excuse me. And also if the nutrients and the erosion upstream, if that's going to increase the amount of blooms in the future. So time will tell on that one, we'll see. And then I mentioned Willow Creek, the ongoing studies going on there with the University of Idaho. And one of their students, Sarah Burnett, she published her thesis paper on the internal loading of nutrients at the reservoir. And she found that this is one of the prime producers of cyanobacteria. So we've got some existing aeration bubblers there, and they're being updated to be used this summer, hopefully, if all goes well. We used them back in, I think it was 2008, but actually it was, it created a worse problem. I think they were going too strong. They were right on the bottom. They stirred up the nutrients from the floor back up into the water column and just created big blooms. So that did not work well. So they're revamping them and they're doing a whole different timing approach. Excuse me. And they're going to hope to extend the oxic conditions into the spring and then promote the earlier turnover of the reservoir in the fall by using these at the beginning and end of the field season. So we're pretty excited to see how this goes, and hopefully it will become effective. It will work this time and shorten that bloom window. I don't know if we'll get rid of the blooms completely, but hopefully we'll definitely shorten it. And that's about all I have. I just wanted to, like Al said, we appreciate the coordination with all the other agencies. They're all been great to work with. And also, I just want to let you know, I'm retiring in May.
But you also can't have that.
Elliot, could you turn off your microphone, please? Thank you.
Thought I heard a little background there. Let's see. Whoops, I lost my, interesting how I just lost my slide, but I'm at the end.
Thank you, Tina. So Frank Wilhelm is continuing to work with you in 2022 on that use of the bubblers, is he?
Right, exactly. Yep.
And I saw that Sarah, his student, is now an employee with you guys. Is that right?
Right. And she's working on completing her doctorate, defending her doctorate. So she's just wrapping that up. But she is working with us full time, and she'll become, starting June 1st, she'll become kind of the main go-to for HAB issues with the water quality section. And then, of course, Holly Bellringer, she's at her office too for assistance. So yeah, we're excited to have Sarah on board. She'll be a good addition to the team.
Susan, a quick question.
Yeah, I do have a quick question and just like a comment. I'm the one who turned in the Fern Ridge Reservoir dog death because it was from a colleague of mine who had worked on Klamath HAB stuff before. You know, it's for someone who works in HABs, it's not really that easy for me even to find who I should be contacting when there's issues with HABs. So as we're talking about communication for the public, for pets, for recreation, I just hope we can make that really clear who people need to get a hold of. And I saw someone in the chat just said it would be good to have a list of people that are working on these things. It would be great for me to have, I'm new to eWeb and I just started here a year ago. So it'd be great for me to have like a list of contacts of who we deal with stuff with. Like if there's a pet death, contact this person. If there's, you know, I was at Subtle Lake camping with my kids and there was a microcystis bloom and I did contact someone. It took a little while, but it seems like it's, we end up playing this email chain kind of, you know.
Mike in this morning?
Right.
Okay. So it's just, if that could be really clear, especially as we're having staffing change and move around, that would be very helpful for some of us.
My first name is Ivers, spelled I-V-E-R.
Ivers, please turn off your microphone. Everybody, please mute unless you're specifically speaking.
ELUMS.
Theo, why don't you mute everyone and then we can unmute again? This is becoming a little bit of an issue.
Can you do that, or
I think if you're the lead, I think you should be able to do it.
Yeah.
If you're the lead, you can go in and individually mute people too.
I'm just looking for it now, though.
And I could give you. Could you give a message?
Hi, Iris. We can hear. Hi, Iris. We can hear you.
Hey, Theo, try clicking the 3 buttons at the top of his thing. And sometimes if you're the admin, you can mute that person individually.
And he called me about a week ago.
Okay, I think I'm muted.
There you go.
Yeah, he's muted now. Okay, sorry about that, Susan. Yeah, point taken. We need, so OHA, Rebecca, maybe you guys, when you talk to EPA, DQ this Friday, that's a point to raise, please.
Because that way, if we, especially in the summertime, we have people go on vacations and all that kind of stuff, and then somebody gets an email, it takes them a week to respond to send it to the next person, which is fine. Everybody has lives and has a right to take off, but it's like, what's the easiest and quickest chain of command to be able to get some kind of response to those areas when we're concerned about HABs blooms? So thanks.
Yeah, I was going to say OHA is a great resource to go to because Rebecca's so good about, she has everybody's contacts and she can reach out to everybody and give us a quick heads up and then coordinate with us and get back to her, get back to you. But yeah, you've got a good point. Thank you.
Thank you.
Yep.
Thank you, Tina. There you go. Aaron's ready to go because we're running a bit late. Go ahead, Aaron. Aaron's from DEQ. He's going to talk about the legislative allocations and the effects that state money has had recently.
All right. Hi, everyone. Good to see folks again. I'll try to get us back on schedule here. Hopefully you can see my screen. It's full screen, I think. So I'm going to talk a little bit about the recent legislative allocations that we received and what we're doing with those allocations and a little overview of what we did last year. Let's see here. Advance. So I'm going to a brief outline. I'll give you 2021 at a glance, the activities that we embarked on, a little bit of a resource timeline, summary of some of our results, some of the challenges we experienced, a little bit about the Labor Day fire water quality data that we've collected and taken a look at, and then look ahead a little bit to the 2022 season. So just to give you a sense of the sort of work portfolio that we embarked on last year, we analyzed approximately 1,600 samples for the drinking water cyanotoxins, remembering that an analysis is one toxin, so microcystin and cylindrospermopsin for approximately 57 facilities. Some of those facilities had to send us additional samples because they exceeded the health advisory level at in the raw water. We did some supplemental cyanotoxin monitoring for municipalities that have an intergovernmental agreement with us. We did cyanotoxin qPCR monitoring for the drinking water project with Oregon Health Authority. We also did work on the innovation project with Region 5 and collected and analyzed samples for them. We did a small amount of recreational sampling, predominantly on the lower Willamette Reservoir, but as was mentioned earlier, some on the Malheur as well. We did a variety of HABs monitoring activities on the upper Deschutes Lakes. So we had a fair amount of analysis that went on in the lab last year in 2021. So I want to give you a brief resource timeline. We got the resources to increase our activities just coming into summer of last year. So, in August, September of last year, we got a second cyanotoxin auto analyzer instrument that was installed and brought up to speed in August and September of 2021. We hired a second analyst using that ELISA method, Stuart Dyer. We're lucky to have him, who was hired on September 1st, 2021. That's Stuart in the lower right-hand corner there. We also hired a field technician, Nathan Reitz, in the upper right, I think in Pompeii, on August 1st, 2021. So brought Nathan on board. But unfortunately, in December of this year, we lost our very capable HABs coordinator, Allison Frone. She returned back to Ohio to be closer to her family. So that was a little bit of a setback for us in terms of sort of where we were at. but we didn't waste any time. We began recruitment for a HABs coordinator in mid-December. And I'm happy to say that we promoted Nathan Reitz to the HABs monitoring coordinator starting in February of this year. And Nathan is in the process of onboarding and getting prepared to do that work, that drinking water work this summer. So continuing along that line, we've already started recruitment for hiring another field technician to replace Nathan. We are in the stage right now where we're checking references for that individual. We've completed 2 rounds of interviews, and we hope to have that position starting sometime in April. We also purchased a nutrient flow analyzer in October of 2021, but supply chain issues really delayed us getting that instrument. They weren't able to provide it to us in a very timely way, but I will say that that instrument came to us last week, finally, and is finally getting installed and should be up and running by, say, June of this year. There's an installation process, then we have to do validation on our methods, some training for the analyst, but we should have that new analyzer up and running this summer. So brief overview of the Cyanotax results from 2021. 56 facilities participated in the 2021 drinking water program. We didn't have any finished water detections, as Greg mentioned earlier. 49 facilities had no detectable results in their raw water. 7 facilities had 40 microcystin detections and 2 cylindrospermopsin detections, and 4 facilities or 16 detections were greater than the 0.3 micrograms per liter for all microcystins, and those facilities are listed below. That is in their raw water. This is just a map of where those facilities were located around the state. The red dots indicate detections greater than the health advisory level coming in the raw water for microcystin. The yellow is less than the detections less than the health advisory level for microcystin, and the blue dots are no detections whatsoever. So just a quick comparison between 2020 and 2021. I just grabbed the 2020 chart from Allison's presentation last year, so they're slightly different format. I apologize for that. But what you can see is the activity in 2020 sort of had some lower amplitude in terms of the number of the value of detections that we were seeing, except for that early detection at I guess that city of Salem at 1.6 in mid-August there. This year we can see that the detections kind of peaked more in September than last year, and we had some detections at some higher levels. On the upper Deschutes TMDL, we've been working in Odell Lake, Crescent Lake, Wickiup Reservoir, Lava Lake, and Lake Billy Chinook at the intake tower in Cove Palisades. We've been collecting cyanotoxin samples, qPCR samples, nutrient samples, conventional water quality parameters, and using satellite imagery. And we've also established some telemetry with DataSonde at Odell Lake. This is Sam Doak here setting up the telemetry, which sends data back to our lab that we can view real time, kind of what's going on at Odell Lake off the dock. Some of the challenges we've experienced in 2021 were supply chain issues, as I mentioned, difficulties getting the instruments in here as quickly as we would have liked. Also just expendable supplies, things like pipette tips and expendables like even jars, because of the supply chain issues, have been difficult to acquire. And when we do find a source, just getting them in on time can be a challenge sometimes. The same goes for instrument service. Getting the vendors to come in and service the instruments in a timely fashion has been difficult, and they've had to provide proof of vaccination, and sometimes that's been difficult to acquire. There's also been shipping delays with UPS and FedEx. They have problems, I think, with workforce delays and disruptions, and that's posed some challenges in terms of getting samples to the laboratory on time. And we had some staffing issues with obviously retaining our very capable HABs drinking water coordinator, and then, you know, getting the recruiting going and onboarding of the staff. So things that, in spite of all these challenges, I think we had some really great work that happened in 2021 that's a tribute to the DEQ lab staff. Just wanted to talk to you briefly about the impacts of the fires, and I'm going to try to get you caught up here, Dan. You know, this is a little bit of data from the South Oban Chain fire and the Alameda fire that I wanted to show you, just when we talk about what the potential impacts are from those fires on nutrients flowing downstream. So the South Oban Chain fire was reported on September 8th, 2020, and contained on October 3rd, 2020. It burned about a little over 30,000 acres. Our station is down here, you know, at the road. Let me see if I can get this. One sec. Is right here, Rogue River at Highway 234. And there's also a gauging station there. So in this graph, what you're looking at is data from all the way from the early 2000s all the way to 2021 for this station. You're looking at nitrate and nitrite concentrations. On the y-axis on the left, you've got the discharge in cubic feet per center as a monthly average. And across the top are the dates for the sampling. And along the sides here are the concentrations for the nitrate. What you can see, the blue bars, by the way, are post-fire results, and the blue dots with the red circles around them are post-fire results for this particular fire. What you see here on January 13th is we had a value for nitrite concentrations that exceeded any value we've seen in the last 20 years. So that's of interest. What I haven't done with this data yet, and it needs to be done, is to adjust for flow, do a load calculation to see how that relates, and try to tease out just flow and see if the fire had an actual effect. This is also for orthophosphate at the same location. Again, we had a 90th percentile value here in the January sampling event. And then looking at the Archie Creek fire, this is a fire that started on September 8th and was contained on November 16th and burned up over 130,000 acres. Same graph. You've got the dates along the bottom, and then you've got the discharge along the y-axis, dates along the top for the samples that were collected, and the concentrations on the right. And again, you see this 90th percentile value over the last 20 years for nitrate, nitrite, and the same thing, a 90th percentile value for orthophosphate. So it is interesting that we're seeing a lot of nutrients coming downstream from these two example fires. So outlook for 2020, we're going to continue to focus on a smooth transition with our new drinking water coordinator to the drinking water program. We'll continue to try to be more responsive to recreational response monitoring needs. We'll continue to work on the QPCR innovation project. The drinking water project's wrapping up. We'll be focusing on the upper Deschutes TMDL work as again this year, prioritizing supplemental monitoring as resources permit, and working with our partners. And I did want to just mention that Nathan, our new drinking water coordinator, has an interesting idea for sort of looking at which water bodies we might consider for monitoring in a biennium. And it's looking at the list of impaired water bodies on our DEQ 303D list, looking at the prior advisories that are listed in the archives of the OHA website, looking at the resolvable water bodies that we can get through the Cyan app, and then usage by the State Marine Board, and then developing an index to sort of rank these water bodies. And I would add, we might want to add something about downstream drinking water supplies, but creating an index to prioritize the list, and then letting folks know that we could do maybe up to 10 water bodies this biennium to focus on, and then submitting that for a public comment of a couple of weeks to see what people think about that list, and then trying to implement some type of activities around that. So I think that's what I have for you today. Any questions?
Thank you, Aaron. Yeah, we're running behind, but that's not Aaron's fault. So let's go for some questions. Yeah, that sounds like a nice rationale to begin with for getting a regular monitoring, Aaron.
Yeah, I thought it was an interesting idea Nathan came up with. We obviously need to do more vetting and discussion of that particular approach, but there could be some good utility to that.
Yeah. Any questions?
You're a big squeak.
Yes. James? James, are you ready? You wanting to ask a question? No? Okay. I think his microphone just came on. Okay. Thanks, Aaron. Thanks a lot. So you can see DEQ's really picked up on activity thanks to some funding that came your way. Oh, I had a question. Of the assays for the drinking water, for the required assays, are they all being done by your lab, or are some being done by other accredited labs? I guess the City of Salem and eWeb are doing their own, right?
For the rule, we do all the facilities identified by the rule, and so some facilities are doing additional sampling of their own accord, but for the rule sampling, we're doing that monitoring.
Okay. Do you think in the future some private lab would be doing that, a business, or will you continue to do all of the assays?
That's a good question. I don't have the answer to. I think if they meet the rule requirements, and if a facility wanted to send their samples to them, that could happen. But currently, the state pays for these samples to be analyzed, so it's being paid for by the state.
Yep. Fair enough. All right, thanks, Aaron. Let's move ahead with the last talk, and then we can have see if there are questions. So that's Dan Sabota, also from DEQ, and Dan's going to talk about the updated DEQ CyanoHABs strategy that incorporates weekly reports.
Yep, thanks, Theo. And actually, this is kind of follows up on some questions earlier about how to find out who to contact and who does what within working with HABs at the state. And so, yeah, again, thanks again for having me. I'm Dan Sabota. I'm with Oregon DEQ. I'm in the watershed management section out of the Portland office. And what I wanted to do today is talk about...
oh, sorry, Aaron, you need to give up your screen.
Oh, are you not seeing mine?
It said it was Aaron's. Yeah, here we go.
Okay.
This is yours now. Yes, go ahead.
Okay, you can see that? Okay, great.
Yep.
Cool. Yeah, so today what I wanted to do is talk about work we've been doing within DEQ, within our harmful algal blooms coordination team across the agency to update the strategy that we have for working with CyanoHABs across the state. I think many of you know Andy Shadell put together a strategy dated in 2011 for how DEQ works with HABs, and had a lot of really good information about HABs across the state. And what we wanted to do is take that document as a foundation and update it to be make it more kind of a foundational or functional document about how to understand how the state addresses HABs. And so within the strategy goals that we have currently laid out for the updated strategy is we want to outline the approach that DEQ is taking to detect, monitor, assess, and manage HABs across the state. Both within our agency and in coordination with partners like OHA, like the Forest Service and the EPA. In doing this, developing the strategy or updating the strategy, what we've also done is been able to identify some gaps in the current way that we've been approaching CyanoHABs and kind of prioritize those for future work within the agency. And then also based on that, then make some recommendations of how we could improve how this DEQ and works on CyanoHABs and expands CyanoHAB work across the agency and in coordination with partners. And so doing that it's been interesting taking the CyanoHAB work at DEQ and trying to organize it in a way that makes it kind of more, I guess, more understandable how to the public and to others how we work with HABs in the agency. And what we've been really divided the work that CyanoHABs is done in DEQ is into 3 broad categories. The first being related to the drinking water monitoring public response, which we work closely with OHA on. Also the immediate kind of public health response to recreational use advisories to HABs, which again we work pretty closely with OHA on. And then finally also how we assess and address HABs in terms of impairments, water quality impairments caused by CyanoHABs and CyanoHAB related factors within water bodies. And so I'm just going to go briefly through and talk about some of the main components. And I will say we have a document that we put together. It's under review right now by our division administrator. We're going to be posting on our website, but it's going to be organized in a way, a web-friendly way, where we can you can go in and take a look at the flow diagrams in terms of how we work together on different things. And how we generally organize this is in the concept of swim lanes, where we have different agencies or responsible parties identified, and then identify some of the main responsibilities. And I'm not showing this here because it's far too busy, but there's also, we show how these different components link together within the strategy. And so we, within drinking water, for example, we identify OHA, public drinking water facilities, the laboratory, and our section in terms of some of the main groups that are working related to drinking water HABs in the state. And then we've identified main responsibilities in terms of, what does OHA do in terms of identifying those susceptible water sources and evaluate the data. How the DEQ lab works with the group to works with OHA and public drinking water facilities to coordinate and analyze samples, as well as how we in the watershed management section provide technical assistance. Recreational, similar approach where we've identified different groups, the OHA program, the DEQ lab. We have DEQ regions that are responsible for going out and conducting sampling or informing OHA about potential blooms. We in the watershed management section provide these weekly satellite reports, which I'll be talking about actually a little bit later on. And we also work pretty extensively with external partners like the Forest Service, like lake managers and whatnot, to coordinate sampling and identify potential blooms. And then finally, with the Clean Water Act, that's mainly within DEQ itself, but we work within the concept of the integrated report or the 303D list to identify water bodies impacted by cyanohabs based on our methodology. And then we develop different approaches, whether that's a total maximum daily load or there's other alternative plans, which such as a watershed-based plan, which we'll be talking about later on today about, that we can then use to manage or try to restore, improve water quality with respect to cyanohabs across the state. And I understand that this is probably pretty busy, but this presentation will be posted and you'll be able to take a look a little bit more, and we'll have the strategy out probably within the next 2 months posted to our website. So from this whole exercise, one thing that there's a few things that we've identified as kind of important needs moving forward with respect to cyanohabs, and some of these probably aren't that surprising, with respect to, say, climate change, for example. We know overall temperatures are increasing across the state, or across the world, and it's having effects on both water availability. We have the fires, we have all sorts of things that are associated with that, and better understanding how those factors may contribute to increasing the frequency, extent, and magnitude of cyanohabs is pretty important, especially from a management perspective. We've also, in the agency itself, overall, we've been really striving towards improving the way, incorporating environmental justice principles, looking at underserved or minority populations, how they're affected by differentially associated with water quality impacts, and that certainly applies to cyanohabs, both from a recreational and drinking water perspective, and also cultural uses as well. And so we're actively working within our environmental justice work group within DEQ to better understand approaches to do that, working with the community in particular about that, the larger communities. And then from that, it may seem a little obvious, but we could always use more funding. But we do identify some specific areas where we could potentially improve funding or resources for monitoring, technical analysis, as well as laboratory analysis. And this will be detailed again also when the strategy is published after review within the next 2 months. But more immediately, one thing that I did want to cover as well is that imminently within the next week or two, we're going to be starting to issue our weekly satellite reports based on the Cyan project that we had started last year and sending over an email chain. But this year, we've actually been able to develop an app. Actually, Yuan Grund, who's on the call, led the charge of this. And I wanted to just do a walkthrough demonstration really quickly if I can get to it. All right, can everyone see the app on the screen, the window? Just get a confirmation from Theo.
What we're seeing is, yes, you're just scrolling past the map of Oregon?
Yes, yeah, exactly. So what I wanted to show is that this is going to be posted to our website and linked in. Again, we're going to have weekly emails that send out that where this is updated, but we are planning to update this on a weekly basis. And this will be, again, available to the public. And we'll send the web link address after we start posting this in the next week or so. I can post that to OLA or have it sent out to the participants of the workshop. But we have essentially an app that we have some information about the data we draw from. And then we have 3 basic sections. Again, an introduction. We have a section where we highlight water bodies that, based on the 7-day average daily maximum, have above 100,000 cells at some point within the water body. I will say that, again, because we, based on the time period that we're reporting right now, we're holding off a little bit because there's some issues with sun angle and maybe ice cover that are skewing the results toward higher counts. But for demonstration purposes, you can see the layout of this. And so we have a list of water bodies that are highlighted for high cyanobacteria cell counts, again, based on this WHO threshold of 100,000 cells. And then in the 3rd section, we actually have a more interactive visualization map where we can go and scroll through all the resolvable water bodies identified within the Cyan project and get a series of the previous 7 days of images for that water body. And as well as getting a time series. And the time series actually is pretty flexible. We have it set currently for starting for the current year. But you can also go and look at the full period of record or snippets of that record as well, if you want, based on this interactive this application. So again, this is kind of and there's some other tools as well, and also the data that we're displaying within these time series plots is also available for download for folks if they want to take it into their own program as well. So this will be coming out pretty soon, and look for that email probably the next 2 weeks. Kind of sped through all that, but I probably have plenty of time for questions, or we can launch into the broader discussion, Theo.
Yes, thank you, Dan. Yes, so let's open the floor to questions, starting with Dan's talk and then going back to, we didn't have time for questions after Rochelle's. There's a question from Megna for Aaron, but let's first give an opportunity for questions for Dan.
Dan, this is Ray Kinney. As far as considerations of water quality gaps that may additively or synergistically affect HABs' influence on water bodies, particularly in the Coast Range. I think 303D listings have been inadequate in the past for alkalinity in water bodies, and therefore for metals toxicology issues that result from more dissolution of metals in those streams and water bodies. So, I think that's a gap that does influence the toxicology of the HABs toxins, additively and synergistically. So it just seems to me like an emphasis ought to be made to take that into consideration more for local issues here.
Yeah, I mean, we can look at specific regions. Alkalinity is a little tricky, especially in Oregon, since we don't really have limestone geology. And so alkalinity is going to be pretty low regardless across the Coast Range. And in other areas, it potentially could influence solubility of some of the metals you mentioned, and how that could contribute to maybe micronutrients. But by and large, more likely within areas such as the Coast Range, like Silk Coast or 10 Mile or places like that, you're probably seeing effects more of increased nutrient loads, say from phosphorus, either from sediment runoff or potentially leaky septic systems, although the data are kind of a little bit washy about that. And there's also invasive species aspects that could be also affecting blooms, especially on the coast.
Also, I think in the Coast Range, in those areas you're talking about, nitrate inputs from red alder vegetation concentrations are, maybe influencing HABs bloom potential.
Potentially, yeah. I mean, a lot of the blooms that we see on the coast, I think, are related more for nitrogen fixing species. And so red alder can certainly contribute a high amount of nitrogen, and it potentially could affect toxicity of blooms. But phosphorus seems to be a better tie for cyanobacteria blooms in many locations, not uniformly. There are certain locations where high nitrogen can lead to blooms, but the red alder question it could potentially be interesting as well.
Yeah, and I think red alder forest management could be a method of perhaps reducing nutrient load locally.
Yeah, we could talk offline about that.
Good. There's a bit of a chat about the resolution, starting with the question of what the resolution is, 300 meters. Rochelle's got an answer, and I don't know, why don't you have a chance to read that, Dan, and see if there's anything to add?
I don't know if I can. I've got you want me to stop sharing the screen? I was going to keep it up in case people wanted to scroll through the app, but I can. I can't see the questions on the chat otherwise.
Oh, okay. Are there any other questions? Well, I was going to go back to Aaron, a question for Aaron. Why don't you relinquish and have a look at the chat and get back to that question, see if there's anything to add. But Meghna, would you like to ask a question of Aaron?
Yeah, no worries. Thanks, Theo. Hi, Aaron. That was a really interesting talk. I really enjoyed listening to some of the stuff you're thinking about. I was just wondering mostly curious about the monitoring prioritization indicators you were mentioning that you and your colleague were getting into soon, and looking at, I'm just curious how you're thinking about it, because as things change, are there opportunities to make it more adaptive? So as lake conditions change over time, how do you make the prioritization process itself a little bit more adaptive to changing conditions? And I was just mostly curious about how you're going about it. That's all. I know you're early in the work, but I would love some.
No, I think that's an excellent question. And I think any prioritization process or scheme that we develop is going to need to be responsive to our improved understanding of factors and situations that we learn about it, because there's just so much about timing and even inter-year variability with blooms that that lend us to learn about what's going on in these different water bodies and how they should be prioritized. So I think we're just trying to identify a starting point, because the reality is we do have, in spite of the fact that we receive these legislative positions, which is fantastic, and more capability, we still have to do some type of a prioritization process. Mm-hmm. And DEQ is a statewide program, so we have to be sensitive to the needs of the state, and we can't just be everywhere all at once. So some way of thinking about which water bodies are prioritized and how, submitting that potentially for public comment, so we can get some feedback from folks that are living across the state, and seeing what we can do and what we can't do, and then saying, okay, we're going to focus on these 10 water bodies. We haven't decided what that looks like yet, but focus on some water bodies over at biennium, and then revisit the list every few years, and maybe increase the number of factors we include as we learn more. But yeah, it's I'm not going to. It is a challenge to figure out a great process for doing it.
Great, thank you so much. I look forward to finding out what you all, how you all think about it as you move forward. This is definitely of interest to me. Thank you.
I also need to mention just one thing. I misspoke about the qPCR innovation project. That is actually a Region 10 project that we're working on, not a Region 5 project. The Office of Research and Development folks work in the Region 5 office, but the project is a Region 10 project. So I wanted to make that clarification. I misspoke during my presentation, so apologies for that.
Thank you, Aaron. Dan, did you have a chance to look at those questions about the resolution? And
yeah, so the first one was Rochelle about the mixed shoreline. Yeah, so one thing I was going to mention is we've taken a little bit different approach than the larger CyanoHAB, where we are including some of the shorelines just for potential screening. Just again, we have that in the disclaimer saying there are some effects that are potentially with that. With doing that, but we figured to be a little bit just to be since this is used for investigatory purposes, that we're including some of those values for the time being. We may remove those in the future as we currently as we think about it going forward.
Yeah, Dan, in the follow-up to Andy Shadell's program analysis of CyanoHABs and needs, and the update that you're doing, who was involved in that? Was OHA involved as well?
For the internal for this current strategy, yeah, we've had Rebecca and Greg both review the sections relevant for OHA and been incorporating their feedback into those sections.
Okay. Any other questions? Going back, say, to Rochelle's talk, any of the earlier talks? Any comments anybody would want to make? I would say with regard to outstanding issues, we've had in this state now for a number of years a standing advisory for the South Umpqua. It's kind of crazy. I think we need to figure out what's going on there and clarify that and figure out what the source of the toxins are and advisories when advisories are appropriate. That is when there are toxins around.
Well, I mean, Theo, we actually talked about that, I think, actually at that seminar, that Roseburg Hydro seminar weeks ago. But I think it's related to there's the potholes that are along the South Umpqua where you have standing water.
I don't believe that, Dan. That's a theory. That can be tested. I think it's probably benthic, but you can test it. It hasn't been tested, and I think it should be.
I'll let Aaron
I really don't think it's those potholes alone. It might be, but I reckon it's probably benthic. But the point is, it's been an standing advisory for ages and ages. And every time Leslie Danglada sends out a report of the whole country, we've got that advisory there, and it means nothing in terms of whether there are cyanotoxins or not, and that's just not very good. Aaron?
If I could just follow up. So I don't know what's right or wrong here, but I do know a little bit about the history of that particular, what drove that advisory. And, we had, I think it was Labor Day, there was some dog deaths down in Elkton. And there was a planned event where there was going to be, playing in the water and kids and fishermen and things like that. And so that prompted a quick response from us at the lab and sending staff down. And they actually sampled around the area where the dog deaths had occurred. The dogs died quickly within I think a half hour or so of drinking the water. And the individual whose dogs died said that they were drinking out of those potholes that Dan was mentioning. We sampled some of those potholes and at the time sent those samples to Greenwater Labs, and they had some of the highest anatoxin values that Greenwater Labs had ever seen. And so the problem became, well, gosh, this situation exists in quite a long extent of the South Umpqua downstream, and it's at base flow or low flow. You get these areas that dry up, but water is standing in these pools, and they do turn very green and nasty looking. And where we trying to be protective of that circumstance over a large area, it became like, are we going to monitor here all the time, or how's that going to roll? And I think OHA kind of wisely decided to put up this standing warning that this situation exists to quite an extent of the lower South Umpqua there that people need to be aware of. So that's kind of where it stemmed from.
Yeah, right. No, I've looked into it a bit, and I've been down there and sampled. But this was all appropriate at the time you're talking about. But this is about 10 years ago, and I don't believe that the samples that came back positive, I believe had about 10 were consolidated from about 10 sample sites. So they don't identify the source. All I'm saying is I think it's about time. It's not to criticise where we are. It was appropriate at the time, but it's been too long. It's a crazy situation, I think, to continue without looking into it. And I would just ask that it become a priority, and that in looking to it, don't assume that it's in those potholes. If it's in the potholes, fine, but look equally at potholes and benthic, because I just don't think it's a clear case. I'm just trying to say that it's an issue that I think we ought to put on the to do and check off and finish and understand list. Yeah,
that makes sense to me.
Yeah.
Ray Kinney comment again. I'm familiar with those potholes down on the Umpqua in general, and do believe that they do often get very high in toxin levels of certain types at times. And each one of those potholes has different environmental conditions depending on the rock temperature and everything and how isolated they are from the mainstream. But I think it also gives us an opportunity to approach veterinary education about the issue, because so many people have their pets down there and they have so much care about the health of their pets that it gives us an in for public education, especially through all the vets that contact those pet owners frequently and can, maybe give us a big bang for the buck in education.
Yeah, the trouble with that is that there are probably many cases of pet deaths or sickness, but very few that are validated. And there can be all sorts of other reasons. There can be different toxicosis, there can be water toxicosis. And so, what you really need is a gut sample. And if a gut sample is obtained, that's really helpful, because from that you can measure toxin that's present in the alimentary canal and that got into the stomach, and you can do genetic analysis to identify what cyanos were there, and then you can make a link to the environment and establish where things are from. But that's hardly ever done. And yeah, when we were doing research, I did over a couple of years try to establish a network so that if there was an event, we would be notified by the state veterinarian, and the state, I can't remember if the state veterinarian did put out a bulletin to vets saying, if there's a suspected cyanotoxicosis, be sure to try and get a stomach sample, because that's important. The thing is that if you do things like, if you rely on post-mortem analyses, they run into hundreds of dollars. So a person is, upset at losing a dog, and they're not always going to have the presence of mind or want to pony up the amount of money to pay for a post-mortem. But a post-mortem is probably not needed. What you really need is stomach contents. Richard, Richard has written, you could speak yourself if you like, or what you're saying is, does the standing HABs warning then also include the Alcton area of the main stem Umpqua, or should it? It's the South Umpqua. Does it include the area around Alcton, Rebecca? I think it probably does. Maybe it's not over.
Yeah, yeah, I'm pretty sure there's a specific area that is covered by that permanent advisory, and it is on the website. I can't remember. I can't quote it, but it is on the website.
I think it surely must go to Alcton, which is not only the South Umpqua. So my mistake. Yeah. Right. Any other questions about things? So we mentioned we're going to have the research talks later, but there might be some other observations. So what about this fairly mild? So that was interesting that we of course, I think in Oregon saw quite a mild summer of HAB activity, but evidently not the case up there in Washington. And some really high hits of Anotoxin were mentioned by Rochelle. And Anotoxin quite high for the first time in Malheur Lake. I had not heard of that before. But certainly Washington seems to have had rather higher activity.
That's right. Yeah, there's quite a bit of activity in Washington and also in Idaho this year.
Yeah. Well,
I know that Malheur has a problem with a huge population of carp, and I don't know what that does for the nutrient load, but I know that a lot of managers down there would like to eliminate a lot of that population of carp, but I don't know how that would affect the nutrient loads.
Well, what I know from Tammy Wood's research there from USGS just before she retired was that it used to be have less open water. It used to have little hillocks that had grasses and stuff. And now it's open water and the wind just whips across it and raises waves, and it's very turbid. So you wouldn't expect much to be growing if it's turbid, because that prevents light penetration. So I don't know.
Well, I think the carp, eat a lot of that vegetation.
They do, yeah.
And when the population is so high, it reduces the vegetation, which then allows the turbidity to go up.
Yeah. No, I think the carp are responsible for the devegetation, correct. But the interesting thing is that it's very turbid, and so you wouldn't expect much phytoplankton growth.
Well, all those carp can stir up a lot of water. I've watched them on the shoreline, and they stir up a lot of mud.
Yeah, in addition to the wind, right?
Yeah.
So we didn't see huge blooms the year after the forest fires, which was pretty interesting. Now, Al, you mentioned smoke, but the smoke would be active in the year of the bloom. So there weren't many fires in 2021. What were you meaning there?
On the east side, there were, Theo. They actually were pretty extensive, and in July, it affected water quality pretty strongly, or air quality pretty strongly.
In 2021?
In 2020, yeah, 2021.
Oh, there were enough. Okay, I didn't.
Yeah, the fires in Idaho and I think also California, there was enough high-level smoke that, I mean, for example, like Odell Lake didn't have a bloom this past year.
Yes, of course there was. I drove down to Sacramento in early August, and it was horrific south of Eugene. Yeah, okay, my mistake. Forgot about that. Yeah, absolutely. That would have a potential effect, cutting down light. Okay, has anybody else got any questions?
Well, also, Theo, also was interesting is that, we saw that heat dome in late June last year.
Yeah.
And, we recorded that in our Upper Deschutes project. So I'll show data later today about that, about how it was like 2 weeks ahead of time in terms of the water temperatures in the Epilimnion in Odell based on that. And so we thought the blooms were going to come early, but they never manifested. And although I think Kaylee is going to show data later today that some of the qPCR results were showing increased production of the genes, but the toxin never manifested, which was interesting.
Has anybody looked at silting and whether silting from, increased inflow after fires above reservoirs led to silt deposition to bury aconites?
That's been hypothesized. I'm not sure it's been shown.
It's been reported in French reservoir. I've read about that. So there was, in that case, there was enough of an inflow from it. Must have been a massive storm that really buried for good aconites. These are the overwintering cells of the Dolichospermum types, and aphanizomenon that can probably last for a few decades. So if they were buried, then the source of the bloom for the next year is compromised.
Just so you know, Theo, you have a question from Megan Skinner.
Megan, go ahead.
Yeah, I was just going to comment on the effects of fires in terms of changes in nutrient load, external nutrient load. And, speaking from the experience of the Klamath Basin, we had a massive fire last summer, the Bootleg Fire. In our basin, our sediments have naturally high phosphorus content. So any increase in sediment load, of course, is going to be concerning, as leading to higher phosphorus load from the watershed. But of course, in Southern Oregon, we are in a pretty severe drought. Our snowpack is well below average. I think it's close to 60 in the Klamath specifically. And, we've had nearly 40 days without, noticeably measurable precipitation, I'll say. And so I think to some extent, in some cases, we'll see the potential effect of wildfires offset by the fact that we're just not getting much inflow because of these dry winters. Mm-hmm. So just a comment and an observation on that.
Yeah. Yep. Thank you. So is OHA DQ people, have you, the state of Ohio, it has perhaps the best developed HABs response, or did have, if you haven't followed it, what they've continued to do over the last couple of years. As you've been thinking about getting up to speed and keeping on innovating, are there things that you've seen in other states, like maybe Ohio, that you would like to see here and that you might work on in the future?
I guess I'll jump in if no one else is. I think Ohio sort of provided a template for us initially when we did the initial response to Salem's water crisis down there. But now I think we've been exploring some of the things that we initially didn't include in the rule, and I'll let Greg speak to that if you would like. But just we thought it would be prudent to investigate the utility of qPCR. I think Ohio has actually included that in their rule, but we needed to do some investigation about how qPCR might or might not work in Oregon before we just put it in a rule. And we're getting information about that now. So I think we're using science to sort of hopefully lead us in the right direction for any modifications. Thinking about how to prioritize, triage, whatever you will, water bodies to monitor, and also provide some sort of statewide coverage as we're responsible for. And so thinking about, the resources we have available to us and how to best make progress on keeping the public informed about risks to public health, and also providing information for watershed management planning so that we can try to impact or positively impact some of these water bodies that have HABs that are either becoming more intense, longer in duration, and try to start working on some of the issues that are contributing to that. So, yeah, I think we're trying to think it through and use science to guide us as we move forward.
So you mentioned that nutrient analyzer that would come online in June or something like that. And you just mentioned about causes of HABs. So can you tell us a bit about what the plan for using that analyzer is?
Well, I think that would be part and parcel with the prioritization process for water bodies that we feel we could sample in a biennium. We wouldn't just collect cyanotoxin samples, but probably we would think about maybe qPCR, some cyanotoxins, and some nutrients to sort of start to characterize what's going on if there are blooms that are cycling in those water bodies, and try to get to those water bodies with some kind of regularity. So I think part of what we hope to do is to start to get a better picture of what's driving some of these blooms.
What analytes are produced by that instrument?
It's a 2-channel instrument, so you can run sort of like orthophosphate and nitrite at the same time. It's basically focused on nutrient analysis, and it should help us to get a little better throughput on some of the things. Nutrients are popular not just with the HABs work we do, but we do a lot of nutrient analysis for the TMDL program, non-point source, our ambient water quality monitoring program, our groundwater monitoring program. So, nutrients are obviously an important driver in water quality in general. And so this instrument will be taking in a lot of important work across a variety of programs, which will help us understand, which watersheds have nutrient issues that need to be worked on.
So is it measuring nitrate, ammonia, total nitrogen, orthophosphate, total phosphorus?
I don't know the specifics of this instrument, like all the particular. It can be set up with 2 channels to run 2 forms of nitrogen or orthophosphate at the same time, but I don't know all the details of the instrument. I could find out.
Okay, thank you. Well, we have 1/4 hour. We're going to restart. We're going to have a break. We scheduled a break at noon until 1, and then we'll start with the research talks that'll go from 1 to 4. But we can either close things down now, or we have a 1/4 hour more if there are further discussions or questions, comments.
Well, I'd like to comment a little more. I don't really want to belabor the riverine pothole issue, but I think in my case on the Oregon coast, we have a lot of pothole issues that really do have different HABs blooms showing up in little micro potholes everywhere. But it becomes a higher public health issue for the local people who frequent those streams in the hot part of the summer, and the whole family goes swimming. But the youngest children get placed in these warm potholes. And if you have a HABs bloom in there, it could be a problem, but it's a combined problem because most of these potholes also become the ashtrays for a lot of the local cigarette butts. Okay, so then you have multiple toxicants becoming a problem for absorption through those young children being placed in there. And not only that, but all the fishing sinkers that get lost in the stream seek the lower levels of those potholes. And then the hydrologic action when those potholes are reconnected during the turbulent parts of the year and grind up those sinkers into very high surface area. And if the water then drops in pH a bit as it reconnects with the stream, then a lot of that can become dissolved lead. And the combination of those potholes as a public health issue, I think, really deserves attention, for signage or for some kind of education. And I thought that doing the education through vets might help with the issue. But at any rate, I just wanted to make everybody aware that there are more issues involved with those than just the HABs themselves.
Yeah, thanks, Ray. Okay. Saxitoxin. We haven't. So, what Megan, you mentioned saxitoxin down there in the Klamath. That's a toxin that we haven't really seen in the state. And if you look at all of the wonderful records that go back probably over 10 years now from the Washington State King County Labs toxin analysis, it's a statewide program. They've analysed a lot of lakes. Saxitoxin and cylindro don't show up very much, interestingly. So those are planktonic samples. Occasionally, no doubt, a slough off of benthic stuff or stuff that from the bottom, or that's growing on rocks, or that's growing on a dam wall, or piers of pylons of a pier or something might come off, and although they're of benthic origin, appear in a planktonic sample. But yeah, so we haven't seen much any saxitoxin. And cylindro, of course, we know from Detroit and maybe now from the upper Mackenzie, but not much in Washington. Mark, have you got a comment about that or something related? Go ahead.
No, I have a question about something else, if you don't mind.
No, fine.
So I'm heading up sort of a review of the program in Washington for the conservation districts in the state on HABs in Washington. And I'm curious, does anybody have a number for what's the total budget for HABs sort of monitoring and response in Oregon, if you include DEQ and health department? You haven't, I don't know, even a ballpark number, like how much is being spent on HABs now?
That would probably be on me, Mark. I could talk to you offline and see if I could get you that number.
Okay, that'd be great. The other question I had.
Oh, I was going to say, Mark, I've also got that laid out in the strategy. I think we kind of documented that in the strategy, which will be published soon.
Okay, good, thanks. I'd like to see that. The other question is, does the HABs program include marine algae at all, or just focused on freshwater, or just?
Yeah,
just freshwater.
Just freshwater for now. We've identified marine HABs as an issue, and it's actually something we're working with respect to hypoxia and high pH, or acidification, I should say, as well in marine systems. But that's a separate issue from the freshwater CyanoHABs strategy.
Of course, there has been for quite some time, a program to test shellfish. That's an ODFW. They do the sampling, and ODA, the Ag department, does the analysis.
Yep.
And that'd be for, that's where saxitoxin is found, but a number of other toxins as well.
Yeah, domoic acid and the like. Yeah.
All right, thanks.
Yeah, good, Mark. Nice to see you. Well, I didn't see you, but heard you. So we heard Rebecca. There you go. Hi. Rebecca, you mentioned salt in silt goose. What's this about? Is salt water penetrating into silt goose because of decreased groundwater or something?
No, so what happens when they have these storms at the beach, and we had that really bad storm, gosh, I don't know, was it a couple of months ago or something like that? I can't remember exactly, but in the king tides, it pushes the sand up into the small river that connects Silk Goose to the ocean, and so it basically causes a dam there, and so the water doesn't have anywhere to go. So kind of, I'm not sure exactly where the salt is coming from necessarily, but when that happened, the salinity went really high, and as a matter of fact, folks who use private intakes and in-home systems, it was just wreaking havoc. Of course, it was deteriorating, the pipes and all kinds of stuff. And so this past season has been a bigger issue than any of the blooms that have formed. So
goodness, that's amazing. Yeah. Well, there's a lot of aphanizomenon in the Baltic Sea. That's been studied a lot. Like the Baltic Sea over towards Finland, south of Finland, is fairly moderate. It's moderated salinity, and so there are a lot of the freshwater cyanos there. There's a lot of nodularia, which is something we don't see a lot here, but that's a microcystin producer, like or produces nodularin, which is pretty much like microcystin. And there's a lot of aphanizomenon, which does okay in some salt. And I think we normally think of microcystin as being quite salt tolerant, don't we? Dan, do you remember? I don't know if
I don't remember.
I'm pretty sure it is considered one of the more salt tolerant ones, but I don't now remember if microcystin is common in that region. It's common in Finnish lakes. I don't know if it's in the Baltic or not. But anyway, aphanizomenon is. So we in estuarine sort of areas where there's some salt, it doesn't at all mean that you won't have freshwater HABs.
Yeah, Theo, that's an interesting concept, because what we have been seeing over the last year is that, it used to be pretty high microcystis blooms would be would form in silkous, and now it's very dominated by so I don't know. It sounds like that might be the salinity, increasing, and then it's just AFA that seems to do a little bit better, because the microcystin, so the guy that's out there looking all the time, he's seeing some Dolichospermum, very little microcystis now, which again used to be the dominant species there. So very interesting change in what's going on.
Yeah.
Well, the surface water in that area around Silkus is, dunal aquifer, and a lot of water is drawn from shallow wells and all, which gets down to the potential for saltwater intrusion to affect the sourcing. And so, the dunal aquifer is important because it's so porous.
Yeah, Mark?
Yeah, I was just going to ask another question about, I was thinking about it because of the coastal lakes. Lake Lytle is a classic example of that saltwater intrusion at high tide. And it has a Lake Lytle on Rockaway Beach. It has a saltwater lens in the bottom at high tide. So, there are several of those coastal lakes, mostly closer to the dunes, in the dunes or close to the beach, that have that saltwater intrusion. The other thing I was going to ask about is, anybody looked at algae or epiphytic algae on macrophytes? Because a lot of coastal lakes, like Silkus, for example, is chock-a-block with aquatic weeds, and they can be a good structure for attached algae. And I know they can cause taste and odor problems. I'm not just wondering if anybody's looking at those epiphytic species that might be toxic.
Kurt Carpenter, you've looked at benthic stuff? Has that included epiphytic on plants or on roots or woody stuff in streams? Maybe Kurt's not with us.
Yeah, so Theo, I can just say in Wisconsin, I know that they have a real issue with Lingbia that definitely grows on other plants. So some of the grasses and things like that within the water body, and they produce toxins there, which have become a problem. So it's something that we're just, we've known about for a long time, but we're just kind of now having, have a little bit more time to actually look at some of these benthic and other species that are out there that are like Theo much more prolific at producing cyanotoxins than the planktonic group. So
I know that in the southeast there's a species of algae that grows on hydrilla that produces a toxin that ends up killing eagles.
That was a science paper. Right.
So that might be something to think about in Oregon as well.
Yeah, that was a very interesting science paper that took a lot of actually decades to finger the producer. Yeah, Dave Donahue, question?
Yeah, I was just going to mention David Donahue over at eWeb. I don't obviously do much work in Silkus, but I'm over there frequently recreating, and the east end by the Ada Resort, I don't really go to the west side or the dam side, but the east end, which is chock full of aquatic vegetation, is probably one of the more prolific cyanobacteria diversity hotspots. Like when I collect a sample on my own time, just to take a look, I'm just amazed at the diversity Certainly aphanizomenon, Gloiotrichia, Dolichospermum, Microcystis. It's just like pretty amazing. And I assume, it's a relatively shallow lake and it stays relatively warm. Probably, no shortage of nutrients. But I think it's probably would be pretty fascinating to look at the other side of that reservoir, away from, any kind of saltwater issues. And just thought I'd throw that out there.
Yeah, that sort of mixture, that reminds me of a sample that we've seen, or samples we've seen from Anderson Lake, which Rochelle mentioned was being sampled. That's one where we looked at and sequenced the genome of the Cyanotoxin producer, because it's had over the years very, very high Cyanotoxin levels. But you can get samples from there where it's got everything under the sun. I mean, it's quite in terms of the cyanos. It's unlike, many of our blooms are actually pretty monotypic. It's kind of interesting, but that's not the case in the Midwest or the South, where it's much more productive in terms of photosynthetic activity. And so I think we're a little bit of an outlier when you look at our cyanobacterial blooms. They're fairly often quite monospecific, but the exception is often those coastal lakes. And so, yeah, I know what you mean. The sample, you'd see all those ones you've listed, and then oscillatoriales, like the Planktothrix type that Rebecca mentioned, which we don't see very much in Oregon, they'll show up, and tons of Warrenachinia, and great big mixture of stuff. Yeah. Which I've always thought is perhaps to do with the fact that they're potentially congenial for, those lakes are potentially congenial for cyanobacterial growth all the year. They just don't get very cold because you have the temperate effect of the ocean.
And once those coastal lake blooms, the bloom may clear, and a lot of the dead material settles out on top of the sediment. Aren't there sources there for dispersing toxins sometimes without visual impairment of the water to be noticed?
Could be, yeah. So if the toxins are intracellular, inside the cells, which means that if there's a scum, it could have astronomically high levels, but the clear water around it might not have that much. But then if stuff dies, of course, the toxin can leach out. So it's a matter then of whether it stays in the water, or it can be metabolized. It can be destroyed by ultraviolet light. It can be absorbed onto clays and stuff, or it can be washed out. So it sort of depends what happens.
Yeah, I have experience as a builder along those lake shores a lot, and realized from doing that how many people were actually sucking water out of the lake. But it made me think that once a bloom is over, if people are educated enough to know HABs bloom may be a problem for their drinking water, as soon as the water clears, they may think the danger's past, but yet perhaps the dead material on the bottom is still letting toxins out that are not visible.
Yeah, for sure. Rich, hi. Question, comment?
Yeah. Hey, Rich Miller from Center for Lakes and Reservoirs, and just wanted to second the concern about Siltcoos Lake. We did some work there back in 2008 and sampled it year round, and there was cyanobacteria, very, very diverse community throughout the year. And of course, there's like the drinking water all around the lake. And, even if there isn't acute effects, there could be a chronic effects there because, full year round of drinking a little bit of cyanobacteria.
Thank you, Rich.
Yes, and another comment from Rich bringing it up is, the chronic low dose accumulative effects potential. We got to keep that in mind all the time, because if we're talking about public health and medical conditions, of course, the effects that are actually happening accumulatively in populations around the lake shores are going to be key to the public health issue.
And Rebecca, you're talking about Dunes City on the west side, probably, are you? Is that the water source, the community?
So there are intakes that, like Rich and Ray have both said, there are intakes that are all around the lake. Unfortunately, where the person that's doing the voluntary work is looking and doing his sampling is definitely near Dune City and around that particular Westlake area, it's called. I totally agree about Ada Park. And that lake is pretty, I mean, it's a big lake. So it's somewhat difficult to kind of get around to all those different areas. But I just wanted to say too that I totally agree with the chronic exposure, and that's something that we have on our radar and that we think a lot about, especially when people are drinking the water and not just recreating in it. The problem too is that there are, that I know of, and I've done quite a bit of research on this, there's only a couple of in-home treatment systems that actually reduce, and it's just microcystin, it's not any of the other toxins, down to that 0.3 micrograms per liter for drinking water purposes. And so I would say that, I don't know that any of those people that are pulling water into an in-home treatment system have one of those systems. So
really?
Yes, they
is activated charcoal, and is that not common in home systems?
Yeah, it seems to be, but there's only a couple where they have been certified to actually reduce microcystin to the drinking water level.
Thanks, Rebecca. Hey, Greg, interesting, the plan to go to a lower level as a warning so that you don't immediately hit the 0.3. It's a very low level though, you know, and so when down in California, they started looking at benthic sources of toxins. And if you look at the lakes assessment, the whole across the country, microcystin is really common. And one could imagine that actually the environment is sort of awash with a very low level of microcystin because it's produced from so many sources in so many places. So that as you got to a very, very low level, you might bump up against, you know, what just is the ambient. So I don't know, just if that's going to happen or not. But is there much experience of monitoring at the 0.15 parts per billion level already?
Yeah, the lab's been using that more sensitive kit since 2020, I think, and I think the the reporting level is 0.08. So we're only talking about setting the trigger level above that. So in other words, they have been using a kit that can measure down to 0.08, and we're still getting non-detects.
Okay.
A lot of detects.
A lot of non-detects.
Yeah.
Okay, good. Yeah. Okay, well, we're at 7 minutes past the hour. I think we can wind up. We've had a nice discussion. Thanks very much to all the speakers, and thanks for everybody tuning in and thinking about HABs and keeping people in Oregon safe. And hopefully we can figure out how to have less of the HABs and keep the landscape safe as well. So thanks again. I'm just going to keep this screen, the Zoom going. So I think you can have conversations if you like, but I'll come back at 1 o'clock or just before, and then Dan and Lara are going to host the afternoon research talk session. So we'll reconvene at 1 o'clock, but I think you can keep using this Zoom platform for discussions and conversations if you like. See you later.
Yeah, and Lara, if you can jump on maybe like at 5 minutes before, so we can just do some brief, quick organization, it'd be great.
Yep.
Sure thing.
Okay, we're recording. I'll just put that up again though, Lara, so that you can mention that.
Okay, I will go ahead and get us started. So welcome everyone. My name is Lara Jansen and I'm part of the Oregon Lakes Association Board of Directors. And I will be moderating this first session of Research Talks. And I just want to highlight that the Oregon Lakes Association's 2022 Graduate Student Award is live and open for applications until April 17th this year. So please encourage any students you know who are working in lakes or in relation to lakes to apply, because it's a really great program. It helped support my work back in 2019. So please get the word out. It will be posted on the Oregon Lakes Association website. So yeah, without further ado, I want to make sure we move through this quickly because the talks are short. So to be clear, what we're going to do is have 4 speakers in a row, and then we will take questions after for a brief 10 minutes, I believe, and then the next half of this session. If the speaker has time within their 10 minutes to have a quick question, that's fine, but let's please keep to time. So with that, I would like to introduce Mark Buettner from the Klamath Tribes. He's been a biologist there for a number of years, I believe, and he's going to be talking today. So Mark, if you would like to take it away, please do.
Thank you and good afternoon. The Klamath Tribes kind of historic homeland is the Upper Klamath Basin. And so the tribe has been very concerned about ecological conditions in the Upper Klamath area. And one of the primary resources that the tribes depended upon were the fisheries in Upper Klamath Lake and the tributaries. So the tribe has had a natural resource program for over 30 years and has had technical staff that have studied the the resources, the water quality conditions, et cetera. So with regards to Upper Klamath Lake, located in Southern Oregon in the Klamath Basin, it's a large, shallow lake. Naturally was eutrophic, but as a result of some degrading land use practices, grazing, logging, agriculture, wetland draining, there was an acceleration, a change in the overall limnological status of the lake to a hyper-eutrophic lake, and also a change in the algal composition of the lake from a diversity of different algal species to one dominated by cyanobacteria, primarily the species of Phanosomena. And so that's the AFA and blue-greens have become more dominant, particularly during the warmer season. And so the tribe's been very active in monitoring the limnological conditions in the lake for 30 plus years. And so we have a pretty long database. We sample about 10 stations around Upper Klamath Lake every 2 weeks from May through October, and have been doing that for a long period of time. That also includes, algal monitoring. We have primarily focused on algal species and composition and abundance. We haven't really been monitoring the toxin microcystin concentrations since 2016. So that's a relatively short time frame. we've generally observed that the toxin-producing blue-greens have been, are relatively uncommon in the lake. Usually the blue-green is dominated by the AFA, and then after the first AFA, Aphanizomenon bloom, when that crashes is usually when conditions are more ideal for the microcystis to bloom, and that's usually about midsummer. So the nitrogen and phosphorus nutrients are more conducive to the toxin-producing microcystis. At that time, with our monitoring, we've suspected that there's been toxin problems in Upper Klamath Lake since about 1996. We had some fish kills, some endangered fish kills during the mid-90s, and there were some initial tests with the microcystis and microcystin that indicated that the fish in the die-off had been exposed to microcystin. So, even dating back, to 1996, we suspected that there was likely some challenging conditions with toxin algae in Upper Klamath Lake. Since 2016, when the tribes started actively monitoring microcystin levels from June through October every year at 5 stations around Upper Klamath Lake, we've documented microcystin levels exceeding the Oregon Health Authority for recreational use every year for at least a month during each of those years. So it's a constant problem every year. So the other thing that I wanted to bring up is that there's been an extensive history of research and monitoring on Upper Klamath Lake over the last 30, 40 years, and the tribes put together basically a website with all the water quality data and reports, and wanted to make that available to the group. And that is at KlamathTribesWaterQuality.com. So I can put that in the chat as well. So there's dozens of technical reports on water quality and limnological and other types of information for the group to look at on when they are looking for some technical information on the area. So with that, I'll conclude my initial talk.
Cool. We have a couple of minutes for questions for Mark. Does anybody have any this time?
I'll ask a question.
Shoot, Kurt.
Hi, Mark. Thanks for sharing that with us. Just thinking about the dam removals that are going to be coming up next year, do you see any changes ahead for how Upper Klamath Lake might get managed?
Well, there's kind of a general assumption that with the dam removal that the fish disease conditions in the lower Klamath River are likely to be less of a concern, as there's more of a natural sediment, dynamics. And so we expect that, right now there's kind of a mitigation to try to reduce fish disease in the river. And that requires release of more water from the upper basin. So if the fish disease issues do resolve to some extent, we would expect that there might be less water needed downstream to mitigate for those disease issues, allowing more natural lake level fluctuations in the future.
That's interesting. Someone else have a follow-up to that? No?
Well, I might bring up one point with dam removals anywhere that need to be considered in concerning downstream fish health and supportive organism health is legacy lead shot from bird hunting and lost lead fishing sinkers and boat anchors and things tend to migrate downslope in the former reservoir into the bottom of the stream, where hydrologic action can increase surface area of the lead, and then that can be a problem downstream too. So a consideration needs to be put in place on perhaps trapping some of that larger particulate lead that's moving down the stream into bedrock traps or something where they could be cleaned out once in a while. But at any rate, it's an issue that I think is neglected largely with dam removal assessment.
Thank you, Ray. I think we need to move on, but we will have time for more discussion and do a few more talks. So with that, I will give it to Dr. Desiree Toles from Oregon State University.
Thank you, Laura. And that was actually a good lead in for one of the things I'm going to be talking about today. Just very briefly, summary of a couple of projects I've been working on related to harmful algal blooms. The first is at Ross Island Lagoon, and the second here is on the Klamath. So I'll just give you a quick update on both of those. Starting at Ross Island Lagoon, this is a picture from this past summer. It was a pretty severe bloom, and it was a lot of OHA, as you heard earlier, did a bunch of sampling out there. Before I actually summarize what we've learned so far, I just want to acknowledge the folks that have been helping me think through and work through this project, and that includes Theo Dreyer here at OSU, Kirk Carpenter, USGS, Willie Levinson with Human Access Project, and then a bunch of agencies from DEQ to DSL, BES. It's been a huge collaborative project, and trying to find some solutions here. So progress thus far, we've done a lot of work to engage stakeholders, broad group of folks. I won't spend much time on that. And the sort of science goal around this has been to understand the current conditions of the HAB and what contribute to it, but more broadly, what we can do to control it and to ideally eliminate the bloom in going forward. So we've done a bunch of work, a bunch of field work, a bunch of modeling, and the idea is to look at a bunch of different alternatives for trying to control this the bloom. The lagoon was generated by a lot of manipulation of the river. There's an earthen dam or berm that was constructed back in the 1920s. There's been a bunch of extraction of gravel. There's a long history there, and so we're trying to figure out what we can do to ameliorate or mitigate the bloom without totally reversing some of the stuff that's happened in the river. So the one I'm going to focus on just briefly is this idea of mechanical pumping. And this is sort of just quick summary of the findings. So first, one of the things that we've come to conclude is that our current modeling tools really, in terms of connecting hydrodynamics and water quality and the microbial piece, are really not adequate for, we can predict biomass, but we really can't predict sort of trends in different organisms and how they change and why they're changing. So that's a place for science. I think we really need to do a much better job. We've got these really great tools, like this is some work that Theo helped with on the using 16S samples, but we need to translate that into modeling tools. And then the second part is on the control side, which is really where my area of interest more is, rather than just detecting the blooms, which is really important work that's going on, thinking about what we can do to control them in situ. And so the cold water pools, and this is relevant to the large reservoirs and dams that are out there, can potentially be a significant resource. So these are just some modeling results of the Ross Island Lagoon starting in January. It's going to go all the way through the end of the year. And what you'll see is the top gets really hot, the bottom stays really cold. And so one of the strategies that we looked at is, well, what if we bring some of that cold water, which essentially is just the winter flows that come in, they're really heavy, and they park themselves at the bottom of the lagoon. if we can bring those up to the surface, does that decrease productivity? And does it decrease productivity both for like the good guys, the diatoms, and for the bad guys? And essentially, well, I'll show you what results we find, but this is a potential solution out at the lagoon. And these are just some quick results. The biomass of the cyanobacteria, again, general cyanobacteria that are modeled as like particles with a certain settling velocity and buoyant neutral negative buoyancy. But this is sitting over the top of the results. The surface is where you see the biomass, and at low pumping rates, essentially we get no effect. As you start to increase the pumping from like 250 to 1,000 gallons per minute, we're starting to see a reduction. Oh, sorry, I don't know what's PowerPoint has moved these slides. They were supposed to be over, or the labels are supposed to be over here. The point is, when you in the hottest, most intense part of the summer of the bloom, you get a lot of reduction, but you have to pump pretty aggressively, like 3,000 gallons per minute. And essentially what it's doing is bringing up the cold water from the bottom and depressing or suppressing productivity at the surface. And it suppresses it both for the diatoms and for the cyanobacteria, but because the cyanobacteria are more sensitive to temperature, we see a much bigger drop in cyanobacteria production. So our next steps out there, we're going to continue. We've got field surveys. We'll be back out there again this summer and working on some design details for the stakeholders. We're going to get some more modeling work that we need to do. And then also we're doing some isotope tracers to try to verify sources of water and some eDNA to verify sources of cyanobacteria. So that's the quick overview on Raw Cyan Lagoon. The next one I want to just quickly give you a summary on is at the Klamath Dam removals. It's something I've been working on for the last year and a half, in particular with Julie Alexander here at OSU and funded by Oregon Sea Grant. So the short of the story here is that those dams are, they store a lot of sediment. It's around 13 million cubic yards, which is about half of what the Elwha Dam removal stored. But a lot of that is organic material. 85% of it is silt, clay, and organic material, and it's just super erodible. We expect it to move out of the system pretty quickly. But in addition to storing those sediments, the legacy of those dams is that they have also transformed nutrients. In particular, I think dissolved inorganic nitrogen, it removes like something like 90% of it. So some of it's just being lost like to the atmosphere. So the fate of those sediments or those nutrients are that they're both the sediments that are nutrients that are both stored in the reservoirs and what's coming from the upper basin is that we expect this short-term pulse of nutrients to come out of the reservoir. Some of that will be with drawdown, which is going to occur in say the January to April, May-ish time period. And so with that winter drawdown, we'll see a flush of nutrients come out of the system. And a lot of that, this is what we found, and people have been studying these reservoirs for a long time. Tim Oten and, I'm blanking on the other guy's name. Anyway, people have been studying these reservoirs for a while. So these are nothing new, but Microcystis aphanosomnon, these are like the Gloiotrichia, these are the sort of common, as usual, suspects in these reservoirs. So we're going to see those get flushed downstream along with their, sort of detritus associated with them. But there's also going to be this continued release as the soil is wet and re-wet. And this is something we've seen in other dam removals, particularly on the nitrogen side of things. But there's also, because those reservoirs sort of acted as compost heaps or as nutrient sinks, and they actually transformed some of that nutrient out of the system, some of the nitrogen like into the atmosphere. The expectation is that we're going to see up to around 50% increase in nitrogen in the lower parts of the river in summer, and a much smaller increase in phosphorus. And on the one hand, that might be a good thing because the lower river is nitrogen limited, but there will be we have some hypotheses about how the food web is going to respond. Because this focus is on harmful algal blooms, I just wanted to quickly summarize what we expect to happen with the cyanobacteria. We expect the reservoir cyanobacteria are going to likely to decline. And we have some hypotheses, again, detailed hypotheses about who's going to replace them in those reaches, the project reaches and downstream. But there are still benthic algae in the system, and it is talking with Laurel Genzoli. We have, again, some hypotheses, but it's not 100% clear what's going to happen with the benthic algae. Are they going to be suppressed by the slight increases in flow and sediment variability? That's kind of the hope, but there's other suggestions that they might persist. So this is a little bit still of a question mark in terms of benthic algae in the system. But what is clear is that beyond the nutrients themselves, the algal dynamics are going to be impacted by how management of flows and water quality. So our next steps are we're trying to continue funding for this work. The sort of nexus for this with Julie Alexander's work, who does the disease risk, is with this guy. This is a filter feeder that actually eats from the reservoirs. It eats the sediment and the nutrients and the cyanobacteria. So we've been trying to understand the connections between the reservoirs, the water quality, and the disease risk downstream through this annelid, this worm that hosts the Ceratinoda shasta parasite. We'll be back out there in the field this summer and continue to build our partnerships and waiting, hopefully, for those dam removals in 2023 or 2024. So that's a whirlwind tour. So many people in partnerships. It's been on both projects. It's been really fun to work with everyone. And I think I'm out of time, but I'm happy to answer questions now or at the Q&A session. Thanks.
Thanks, Desiree. Yeah, let's save questions for after. And I will move to the next speaker, Maya Fortuo, who is a master's student at Portland State University, will be presenting next on her thesis work. Maya, whenever you're ready.
Perfect. Can everybody hear me?
Yep.
All right. Hi, everyone. My name is Maya. I am a current master's student at PSU in the Environmental Science and Management Department. My research is on the analysis of harmful algal blooms in the Willamette, specifically in the Portland metro area. My PIs are Dr. Starry, Dr. Morse, and Jennifer Morass from USGS. I also have collaborators, Laura Jansen and Dr. Jean Foster from DEQ. So this project is a pilot project through UPP, the USGS Portland State Partnership, and a lot of it is preliminary sampling to get a better idea of what we want to do or proceed with in the following academic year. So quick background on the Willamette. I mean, we don't really need thorough background on this, we already know, but essentially the Willamette flows northward and most evident blooms that we are seeing in the Portland metro area are from Ross Island Lagoon, as Desiree mentioned. And the cyanobacteria that have been found in lakes in the Willamette Basin have also been found in the Willamette River, as USGS has stated and has found. And public health concerns are only increasing with cyanotoxins such as microcystin, anatoxins, and the other toxins that we have discussed already today. And this research project is unique for its focus on a large riverine system. A lot of the studies or previous studies that I've looked at and analyzed, they conduct climate models and they conclude that more research needs to be done on these large riverine systems because they're so complex. And there's a large number of factors that could contribute to blooms in these systems. And we also are focusing on public health for the metro Portland area. And going into what microcystis aeruginosa is, again, we already know, but just reiterating that it releases microcystin and it thrives in these warm, turbid, slow-moving waters, which is why it does so well in Ross Island Lagoon. And in humans, when it's ingested, it can cause vomiting, diarrhea, just general lethargy and weakness. And just skin exposure can cause irritation, rashes, burns, and there have even been reports of severe skin abrasions. And in dogs, as we've seen also earlier today, it's extremely harmful and damaging to them, especially if you let them swim in there, because they can ingest the water, cause liver damage, and even when they're cleaning themselves, the algae that gets attached to their fur, they ingest that as well. And blooms are expanding worldwide due to eutrophication and temperature change, and that temperature change is going to be what I would like to focus on in my project. So going into what my research project is about, I had a whole stream of research questions that I wanted answered, but obviously I can't go through all of that in a short master's thesis. So I had to break it down. But essentially, this is what I wanted to figure out. What toxins are present in the sites, which sites are most promising, what factors influence these blooms, does climate change, again, the temperature changes, have a significant role, and how are humans impacted by these toxins? Again, emphasizing on that public health aspect. And these graphs up here, I I extracted from the USGS data retrieval. It just compares the pattern of chlorophyll A, our indicator, and temperature. And as you can see, there seems to be a relationship in the increases and the peaks. Going briefly into the methods and experimental design. So like I said before, this is a pilot project. We did some preliminary sampling in summer 2021. I believe it was early August. It was the second week of August. We selected 3 sampling sites in proximity to Ross Island and deployed spats in those sites. We left them for about 7 to 8 days because considering the recent bloom that had occurred during that time period, we figured that just a week was enough time to get a good idea of what's present in these at these sites. So after that week-long period, we retrieved the spats and then extracted the toxins from that from the resin in the spats, then put them through analysis in the ELISA kit. And in addition to analyzing our results, I also took the liberty of comparing historical and current data from, again, the USGS database. Here's a close-up of our sites that we chose. So upstream of Ross Island is Selwood Riverfront Park. Downstream is Audrey McCall, and it's not labeled on Google Earth for some reason, but it's Fire Station 21. And for the sake of me not having to repeat all those long names throughout, I'm just going to call this one Site 1, Site 2, and Site 3. So going into the results, after putting our samples through the ELISA kit and the plate reader, we got the raw absorbances and calculated the concentration using the Abraxas solver. We divided the concentration by the dilution, which is a 1:10 ratio, the grams of resin present in the spats, which was 3 grams all throughout, and the amount of days that we left them at the sites. And when you look at these values, obviously they're not to the extreme concentration that's harmful for for drinking water or anything like that, like we've determined before. They're fairly low. However, that's not really the point of these results. It's just to show like there is something in those sites that could be of concern. And you can see here from sites 1 and 2, they have greater microcystin concentrations than site 3. So we will be focusing on temporal sampling for these sites in the future sampling. So why sites 1 and 2 have higher concentrations? There's a lot that could cause that. There are a lot of factors that, again, contribute to blooms in large riverine systems. However, looking at current USGS data or continuous USGS data, I looked at those time periods, those sampling periods, and for sites 1 and 2, the temperature was higher than site 3, as well as the nitrate levels and the chlorophyll A levels. Those were also greater in sites 1 and 2. In addition to that, sites 1 and 2 are downstream of Ross Island Lagoon, so it would make sense that there's a greater amount of microcystin or greater concentration of microcystin at those sites than at the upstream site. As far as next steps go, I would like to, again, focus on temperature and how that influences river blooms in the Willamette. As climate change continues to increase the temperature annually, I would like to see how that is affected. And I'm looking at historical data from USGS and DEQ, seeing whether there is a pattern that I can follow, and it looks promising so far. I would like to sample more at the first 2 sites, Fire Station 21 and Audrey McCall, because again, those had the higher concentrations, and those are highly recreational sites. I plan on sampling from June to fall, which is the typical sampling period that USGS and DEQ have kind of reached the consensus, like that, yeah, this is where we see a lot of microcystin productivity or microcystis productivity. Looking at other cyanotoxins is also possible, but that depends on resource availability. And we also plan on conducting a social survey on public use and recreation, because all of these sites that we selected, a lot of people they do a lot of activities at these sites. They swim, they boat, they fish. So it would be interesting to see if they are aware of to what extent these algal blooms could endanger them or harm them, or if they are even concerned about these cautions or precautions that are put out sometimes in like those weekly warnings that we get in the summer. And if anyone has any questions, I'm not sure if we have time left.
Take one quick question.
Okay.
All right, I'll ask one quick one, Maya. I noticed that you were thinking about dropping the Upper Selwood site, and I guess I would just say that if it's possible to keep that one in there, that might be really good to keep, because I know there are blooms that come down the Willamette. You know, I think they're worst up above the falls there, and then that material can come downstream. And I mean, that picture that Desiree showed of Ross Island Lagoon and how glowing a green it was compared to everywhere else, you know, that is often what we see with the satellite. So maybe not so much, but you know, if you were seeing some detections up there at Selwood, I might, you know, think about continuing that.
Yeah, I'd like to reiterate that too, because I know OHA has been interested in, and also just the tidal influence. Our models suggest that it can sweep flows out of the lagoon and sweep it up to the Selwood area. So yeah, the upstream reach isn't necessarily isolated because it's so tidally influenced from the lagoon.
Yeah, it's very interesting learning about how the tides can really affect a lot in the Willamette.
Great. Thanks, Maya. We can talk about it more at the break. I'm going to move it now on to Taylor Dodrell, who is also a graduate student at Portland State University, who will be presenting on her work. Taylor, take it away when you're ready.
Cool. Thanks, Laura. Can you see that and hear me okay?
Yep.
Okay, great. So I just wanted to start off by showing this picture, which is, you know, by now at this point in the day, pretty familiar to you all. But this photo was taken at 10 Mile Lake in August of 2015. And you can see it's a pretty severe cyanobacteria bloom happening now. And unfortunately, these have become a somewhat regular occurrence at 10 Mile Lake. However, this photo was actually taken this summer, August, not too far away from the first photo. And you can see that the water is distinctly lacking in that acid green color. So kind of echoing some of the thoughts from earlier this morning, we kind of had a somewhat better year for CyanoHABs at 10 Mile Lake this year. So that's what I'm going to be talking about today. Our unusual summer of HAB monitoring at 10 Mile Lake. I'm Taylor Dodrell. I'm a PhD student at Portland State University. And my co-authors who really conceived the idea for this monitoring work and have been mentoring me a lot along the way are John Schaefer, Ashley Russell, and Janet Neisner from the Confederated Tribes of Coos, Lower-Umpqua, and Siuslaw's Department of Natural Resources. Okay, so our work at 10 Mile Lake is actually a part of a larger HAB monitoring program that we're trying to pilot in the Coos Bay area. And it's planned that we're going to do some sampling for 2 years. We're about in the middle of that right now. And we have expanded sampling effort in the summer months, which is where our sampling at 10 Mile Lake comes into play. So these heat maps are just showing some of the toxin testing that we've been doing as a part of that larger program. You'll notice that most of the sites are actually in the Coos Estuary and South Slough Estuary. And we haven't really had any notable cyanobacteria blooms in the estuary. So today I'm just focusing on the 10 Mile Lake site, since that is where we've been seeing issues. And unfortunately, this last summer, we did detect microcystin at 10 Mile Lake. And at one point, it was above the drinking water advisory. So even though it seemed like the bloom was knocked down, like we weren't seeing any surface blooms, it unfortunately does not appear to have been fully knocked out. So just to give you a bit more background about 10 Mile Lake, the 10 Mile Lake complex is a series of several lakes. And the entire area is really important for the tribe. And Patty Wherrett-Phillips, who's the tribal linguist, noted how historically this area was really valued for its alder groves, healthy lamprey runs and fisheries, and for wapato gathering. Today, it is also very popular for recreational activities, and there are lots of vacation homes on the lake. And the place where we're specifically monitoring is called Camp Easter Seal. It's highlighted in the red on this map. It was constructed in 1948 and purchased by the tribe in 2014 with the intention of using this really beautiful place as a site for hosting tribal youth summer camps. But unfortunately, the cyanohabs at this site have been so bad in past years that these summer camps have had to be indefinitely postponed. And in addition to that, these blooms have caused residents' drinking water to be compromised. To my knowledge, most people are not pulling water from the lake, but there are a few residents who are and have had to switch over to drinking bottled water when this happens. There have been toxin exposures during recreational activities, and as this picture shows, some fish die-offs as well. So the 10 Mile Lake Basin Partnership is, aware of the situation and has been working to address this issue for quite some time. This bar plot is showing some of the monitoring work that they did from 2004 to 2012. So you can see the blue bars in this graph are showing the blue-green algae component of the algal assemblage. So you can see it's pretty prevalent and persistent over multiple summers. But unfortunately, to my knowledge, this work has not been continued. So we tried to pick up the monitoring again this summer. And in a similar sort of bar plot here, the dark blue-gray color is representing cyanobacteria. You can see again that they're very prevalent, despite the fact that there wasn't a visually observable bloom, at least by the naked eye. But I do want to point out that at one point during the summer in August, diatoms, which are represented by this lighter blue color, actually were the most dominant algal groups. They sort of overtook cyanobacteria for a while. And within that group of diatoms, we were seeing a lot of this species called Elacosyra angustissima, which is a chain-forming spiny diatom. We saw lots of those. Unfortunately, we also saw some of the other usual suspects like Dolichospermum planktonicum and Microcystis aeruginosa. So, even though we are still seeing these cyanohabs occurring to maybe a lesser degree, I think it's interesting to ask the question, what caused this knockdown in the typical HAB magnitude that we would normally expect to see at 10 Mile Lake. So, of course, we wanted to look at the nutrient profiles for the lake. And just to keep things short, I'm going to do some very brief conclusions from this, but some interesting things we saw were that silicic acid showed a very sharp decline right around the time of the big diatom peak that we saw in August, which makes sense given that diatoms use silica to build their skeletons. We also noticed that a large portion of the dissolved nitrogen and phosphorus is actually in organic forms, which is interesting because that could potentially help us rule out some possible nutrient inputs, and also is relevant because most algae tend to take up dissolved inorganic forms of nitrogen and phosphorus. And finally, we saw that there was a pretty strong uptick later in the season in most nutrient forms. So in September and October, we saw most nutrient forms increase in concentration. And we suspect this is probably because it started raining in September. So this sort of seems to suggest that a lot of the nutrient inputs at this site are from runoff. So we're probably looking at non-point sources here. We also wanted to look at temperature to see if there were any anomalies this year that could have influenced the changes that we saw, but it very much mirrored prior years. Also, unfortunately, we lost the first half of the year of temperature data, which brings me to another interesting factor that was at play this year. So these freshwater bryozoans, we think might have formed a colony on the first temperature logger. That might be why we lost it. This photo is showing the second temperature logger that we pulled up in October with a big colony of these bryozoans around it. So these are colonial filter feeding organisms, and they really haven't been present at 10 Mile Lake in any noticeable numbers before this year. And this year, like you really couldn't miss them. They were everywhere, washing up on shore. So I think it's potentially an interesting question of whether these filter feeders were influencing the biomass of algae at this site. So we're still in like the really early phases of looking at these data. And at this point, we've kind of generated more questions than answers about what's going on here. And we have more monitoring to do still. So luckily, there's some exciting things coming up in the future. The tribe recently purchased a flow cam, Cyano. So we're hoping that that will kind of help make these algal monitoring programs, which can be pretty labor intensive, more resilient into the future. Okay, thank you. I don't know if there's any time for questions or not.
Yeah, so there is now actually a break in our session for questions. So you all can open this up to questions for Taylor as well as the following previous, the previous speakers. So we have until 1:50. If anybody has questions for Taylor and others. So Taylor, can you clarify that scum that you had on that very first slide, that was from a previous year where you typically see it, and it wasn't like that at all in 2021? Is that what you mean?
Yeah, the first photo was, I believe, from 2015 in August. Okay. And yeah, we didn't see any of that over the course of our monthly sampling in 2021.
And what's the species that usually dominates in that scum?
I think it's usually Microcystis, but I'm kind of new here, so maybe John can. John, I think, is on the call. He might be able to elaborate a bit.
Yeah, I'm not 100% sure. But both those pictures, you saw the really thick one, but there was another picture. It showed a tribal member scooping out. That was actually at Camp Easter Seals. That was the same year. I think it was a week prior. It wasn't as thick there, but that thick stuff is a natural catch. The wind blows it and makes it extra thick there. So it's normally worse there than anywhere else. So that's worst of the worst. You wouldn't see that that density over the entire lake or even most coves.
Okay, cool. Kurt, you have a question?
Yeah, I'm just wondering if anybody's looking at the zooplankton in the lake. I note the Alcasira and the spikes. I often will see that organism in places that have a lot of copepods or a large number of rotifers, and sometimes in some really heavily grazed systems. That's all you'll see are these what I consider more. It's a diatom, so it should be a good food source, but those spikes are kind of gnarly. So that might be worth looking at the year to year. There's been, you probably have heard, the ocean is doing a lot better, and one of the reasons why they say is because of an explosion in copepod recruitment, and so maybe that could be having some secondary effects there. Just a thought.
Yeah, that's an interesting thought. Unfortunately, we weren't looking at zooplankton, but yeah, I agree with you that those spiny Alacasira probably don't make for super super good food sources. Okay, Stuart Dwyer, I think you were next. Question, Dwyer. Stuart, are you there? Okay.
He put a comment in the chat about the bryozoan there. I wonder if
Yeah, maybe that was it. Okay. Theo, do you want to go next?
Yeah, Maya. Richard Litz used to be on the OLA board, and he lives on 10 Mile Island Lake, and used to work for the Watershed Council, and then didn't, and then I think does again. Is he involved in your study, or have you been communicating with that group?
No, I haven't connected with them actually.
Yeah, it's Richard Litz.
He's no longer
sure
with
he's working for the Watershed
Basin
Council.
Partnership, although he still lives on the lake.
Oh, okay. Yep. All right.
And he's been doing lamprey work, although that grant just ended. It was lamprey grant with the tribe.
Okay. All right. Thanks.
But you're right. He's very knowledgeable and would be good to check in with.
Yeah, he had a bunch of the bryozoan on his dock, like more than he's ever seen. So then we got reports all over the lake about what are these things. Although I've seen them in the past in the lake, just single ones, but I've never seen anything like this.
Yeah, it's worth pointing out we have those in the Willamette. They get onto our monitor pretty badly. I've also seen them in the Tualatin. So I don't have the highest regard for these organisms. I think Stuart Rounds actually brought some back and tried to look at the isotopes and dried some of that material out. And I tell you, nothing, it smelled so bad. We're all still struggling with nose injuries from that. Don't get them on your hands.
Aaron Bosenko, do you want to ask?
At least you know you don't have COVID, Kirk, because you can still smell. My question is for Dr. Tullis. Dr. Tullis, I'm interested in the work that you've been doing on Ross Island Lagoon, and I'm wondering about the potential energy cost of circulating that much water. Have you done any investigation of sort of what it would require to move that volume of water?
Yeah, I'm also concerned about it, not just from an energy perspective, but also from a carbon perspective. And I have the numbers, I don't have them off the top of my head for running in a single pump, but it all depends on how long it's being operated. You know, is it being operated for 2 weeks? Or is it being operated for 3 months, 2 months? And how many pumps are we operating? And so that's what's happening in the next phase of the project, is to finalize that as a design strategy. I did reach out to SolarBee to talk to them about using their, their electric or their solar pumps. But the challenge with that is that they essentially, it's kind of like empirical. They don't really have, and their circulation is like, they don't do really vertical circulation. It's more circulation above the thermocline. And so it's a very different mixing mechanism. And they also don't have any results, like really that they can share that demonstrates why it's effective in some places and a total failure in other places. So I'm hesitant to go that route. I mean, our alternate strategy is to build a solar pump from scratch. And when you're, talking about 3,000 gallons per minute, that's a big effort and totally different sort of design strategy. But I know, the cost of those, of a submersible pump itself is not that expensive, but, a generator itself would be like $100,000. So it's not a cheap option. And I do have concerns about the energy and carbon footprints of doing that. But I think that it could be operated strategically so that it's not being run all summer. And so that's where they were trying to sort of focus as a solution, focus it to, not just sort of blindly run it all summer, but to do it strategically so it's being operated for the minimum amount of time.
Thank you.
Yeah.
All right. Mark Sisma, do you have a question?
Back to 10 Mile for a minute. I would just point out that the Pectinatella is an introduced species in Oregon, so that's non-native in 10 Mile Lake, that bryozoan, as is most of the plants in the lake are also introduced. So just because I work a lot on invasive species, I just want to take a opportunity to point that out. The other thing is, Taylor, when I many years ago, 30 years ago, when I was doing work on 10 Mile Lake, I looked at, I'd have to go back and look it up. I can't remember what I did exactly, but there was a good correlation between springtime temperature and August chlorophyll A concentration. So my thinking when I did this work was that, when it's warm in the spring, sunnier springs allow the phytoplankton populations sort of build up. They get more generations in a year, so that the populations can build up over the summer. So anyway, that was a long time ago, and it was very preliminary work. But there's a lot of data on 10 Mile Lake. I think Joe Eilers did a lot of work on 10 Mile Lake as well back in the day. So it's something to think about anyway.
Yeah, that's super interesting. And that's kind of our next step plan, is to start comparing this with some of the historical data that's out there. So we'll definitely look into that. Sounds cool.
Kurt, you got a quick question?
Yeah, real quick. So along those lines, the question that I have is the wind. Have we seen shifts in the wind patterns that have causing maybe, destratification for more frequent periods? Something that I think needs to be considered for that year-to-year variability and trying to understand what happens in a particular year. So if you haven't looked at those annual wind patterns, and especially like Mark said, in the springtime, might be good, because some of those, I'm not sure exactly where those temperatures are being taken, but those surface temperatures can really get interrupted by a few days of good wind. And it seems windier, but I know that's something like with climate change, people are looking at changes in those wind patterns. So.
Great. I think we'll move on, and we will start the session again with David Donahue from eWeb. He's, I believe, an environmental associate. So David, whenever you're ready to start.
Great, thanks a lot. Hey, can you see that? Excellent. My name is David Donahue. I'm an environmental specialist with Eugene Water and Electric Board, and I was going to give a McKenzie Watershed HAB update, a brief update. Thanks for having me. So just high level, eWeb supplies drinking water to approximately 200,000 folks in the greater Eugene area. This map is a map of the McKenzie Watershed, and you'll notice about halfway up, we've got two large Army Corps reservoirs. On the north side of the main stem McKenzie, we have Blue River Reservoir. And on the south side, we've got Cougar Reservoir. Unfortunately, those reservoirs are not on the main stem. They're off on side tributaries. And then moving downstream, we've got a handful of main stem sites that we monitor frequently, going all the way down to that E010 site, which is a McKenzie River at our intake. And that's about 45 miles between the reservoirs and our intake. And a big focus of much of our HAB monitoring. So similar to previous years, our current year, 2022 monitoring plan is beginning in March. Actually, this morning, our field technician, Lisa Urquhart, was already up at Blue River and Cougar Reservoirs grabbing some samples, thanks to Lisa. But we do visual assessments throughout the year, qualitative algae assessments. That includes net tows, benthic scrapes, and we look at those under the microscope in-house. We've got a lot of permanently deployed sondes, but we also have sondes out whenever we're out in the field, and we're certainly after the chlorophyll phycocyanin signals, as well as FDOM. Beginning in April and going all the way through October on a bi-weekly, every 2 weeks, we're collecting algae identification and enumeration samples, which we send to a private lab. We're also collecting cyanotoxins. Fortunately, our eWeb water quality lab has redundant automated ELISA systems in-house, so we can process those toxin samples and get pretty quick turnaround times, especially if there's bloom conditions. So really fortunate to have that and a great in-house staff to do that. They also do all of our nutrient sampling in-house. So it makes it pretty easy for shipping. You just have to walk across the parking lot. And we also do toxigenic gene testing using qPCR via a private lab. And we typically focus on the reservoirs, but if we have blooms or other issues, then we'll expand that qPCR testing. Every month, we're also out doing a monthly profile by boat. So basically, we're going out and sampling at depth to see how concentrations, toxins at depth are comparing to our surface samples. So this plot is from last year, and it's Blue River and Cougar Reservoir, and I've plotted two things here: the Dolichospermum concentrations, which is typically our primary cyanobacteria in both reservoirs, and also the Cylindrospermopsin gene concentration using qPCR. As you can tell, we tend to see, and this is pretty typical, a spring bloom starting in April, and we'll often see those qPCR results indicating Cylindrospermopsin genes are in the system, rising pretty quickly, followed by increasing Dolichospermum numbers. One thing of interest is last year we actually didn't have any toxins reported above the method reporting limits. So for the most part, non-detect. In previous years, we have had Cylindrospermopsin production in both Blue River and Cougar, fairly low level, but it generally follows the same pattern. You'll get qPCR results for the genes, followed by increasing Dolichospermum numbers, and then you'll see your Cylindrospermopsin concentrations come in. We sometimes get a late fall bloom, especially in Cougar for Dolichospermum, but we don't really see any genes associated with that or toxin production. And I didn't plot it on here, but even before the Cylindrospermopsin genes that we see, we'll have a big diatom bloom. So usually both reservoirs get kicked off, probably starting about now with a significant bloom of Stereonella. So that knows we've started the cycle again. This is just a closer look at Blue River Reservoir. The purple line is that Dolichospermum number concentration. One thing of interest, though, this last year, which we haven't really seen in previous years, is in June, July, we had additional peaks of Planctolyngbia and Cyanodictyon, which we have not seen really in previous years. Concentrations got pretty high in Blue River. We didn't really see toxins, and I'm not really certain that either of those genus are associated with toxin production, but this is all post-holiday farm fire. So there is some interest in understanding if things are changing, particularly in Blue River Reservoir. For Cougar Reservoir, again, we primarily just see Dolichospermum, a big spring peak, and then typically another later fall bloom. The last several years, we've actually been seeing late fall aphanizomenon coming in. You can see the blue dotted line there at the far right of the chart is our aphanizomenon, and that's becoming pretty routine. We'll see that sometimes all the way into mid-November. This is just a look at peak Dolichospermum concentrations over the last, over the last 30 years. We did do quite a bit of monitoring back in the 90s, and so that's a good piece of data to reflect back on. But you can see over the last 10 years or so, concentrations generally are higher in Blue River reservoirs compared to Cougar Reservoir. And last year wasn't too far of a departure from what we've seen over the past 10 years, as far as peak concentrations at any point in time across the reservoir. One thing that we are doing a lot of monitoring around is the holiday farm fire, which happened with the Labor Day farm fires, our Labor Day fires back in September of 2020. We're doing a lot of monitoring in, around, below, and above the holiday farm fire. And Aaron mentioned this, a similar observation is that we certainly are seeing some higher nitrate levels in the system. I just pulled this plot out of Gate Creek and McKenzie River at Hendricks, which is quite a bit downstream of the fire. But those values, nationally probably aren't that high, but for the McKenzie, anything above 1,000 micrograms per liter is pretty high in our system. So how that influences benthic growth, those are some of the questions we're kind of hoping to answer. And speaking of which, last year we did start some work with the USGS, Kurt Carpenter and others, looking at periphyton in the system, and also doing some hyperspectral work. The photo on the left is actually the USGS team actually taking some hyperspectral measurements of some of the periphyton. We collected samples from 12 sites back in September. We composited probably 10 subsamples at least from each site. We used a field blender, and then we sent those samples off for toxin analysis and qPCR analysis. I think looks like we had the minimum of 15 cyanobacteria taxa were observed. Of interest, we don't typically see microcystin anywhere in our system. We don't see it in the reservoirs. Kurt, with our SPAT deployments, did find some associated most likely with benthics, but we did have some microcystin detections in several of the concentrated benthic samples, which isn't that surprising. There's quite a diversity of cyanobacteria in those. And we also had 2 hits for saxitoxin genes up in the upper watershed. So that's something we certainly want to follow up on this year, and we're going to be continuing that work in 2022. I'm sure Kurt will speak more about that. And lastly, just a couple of additional opportunities. We're really certainly excited about the Army Corps USGS effort to get the profiler in Blue River Reservoir. That tends to be our more problematic reservoir, so it'll be great to get that depth profile in there continuously. There's a lot of emerging technologies being discussed, and one of them that we're excited about is over at OSU at Department of Microbiology with Dr. Halsey, Dr. Fox using VOCs as a proxy for cyanotoxin. So we're really interested to see how that develops, and also exploring how we can use mapping remote sensing options to better, certainly outside of the McKinsey, but to give us a little bit better temporal spatial capabilities for looking at reservoirs in adjacent watersheds. We are probably going to be going down the path of a second source on the Willamette. If we do, that would be opening up what's going on in the Coast Fork and the Middle Fork watersheds. And I think the mapping remote sensing technologies can give us the capabilities to look at over a much wider area more quickly, because spending the resources we do in the McKinsey and other watersheds would certainly be a challenge. And with that, I thank you for your time.
Awesome. Thank you, David. Don't have time for questions just yet, but at the end of the next 2 speakers, we'll have some time to ask David questions if you'd like. With that, I will switch gears to Dan Sabota for DEQ and Alyssa Peter.
Great. Can I just get a confirmation you can see my screen?
Yes.
Okay, cool. Thanks, Laura. Well, thanks again for having me. Today I'm just going to spend a few minutes talking about work that we've been working on in the Upper Deschutes watershed the past several years, looking at cyanobacteria blooms in several lakes and reservoirs in the area, and then shift and talk about some future work coming up with Alyssa taking the lead on that in the next several years. So to start with, I want to thank my co-authors, by the way, Steve Hansen, Smina Mehta, and Sam Doak. They've been really essential to the work of this project. The objectives we have for work in the basin is the primary one is we're trying to test the capacity of using satellite imagery to identify, predict, and monitor cyanobacteria blooms in the area. We want to compare the satellite-derived estimates of cyanobacteria abundance with also with in situ water quality measurements, including things that characterize algal biomass like chlorophyll A and phycocyanin, as well as other metrics such as pH, dissolved oxygen, and temperature and whatnot. And then ultimately, what we're trying to do is, especially within kind of individual basins or regions across the state, is determine how we can use a combination of both satellite imagery and in situ measurements to help identify what factors are contributing to blooms within particular areas or particular systems. So with that, the area that we've been working in, again, is in the Upper Deschutes. I've highlighted here the area of the different systems we've been working on specifically, and also ones that we're going to be working on in the future. Beginning in 2019, we instrumented Odell Lake and Crescent Lake with sondes starting in spring and running through October, where we've been taking continuous measurements. Aaron talked a little bit about some of the metrics and technologies we've been using at these systems or these lakes thus far. We've also worked a lot in Crane Prairie Reservoir the past 2 years, as well as Lake Billy Chinook last year. We're actually not going to be doing it this year, though, based on some resource allocations. But we are also working, expanding work into Lava Lake and the Deschutes as well this year, and hoping to have a sonde instrumented there. We've also done some periodic sampling of Davis Lake, Wickiup, and several others in the watershed too, just to get a sense of spot measures of water quality and check that against satellite imagery. What I'll show today just is well, let me talk about the methods first, I suppose. So we've been, again, I mentioned we've been conducting sampling from spring through summer to fall each of the past 3 years. 2020 was a little challenging given COVID travel restrictions. We were actually able to get continuous data collected at 3 locations. We've also, so we collect using sonde, again, I mentioned chlorophyll A, phycocyanin, DO, pH, and temperature. We've also corresponded that with every 2 weeks collecting microcystin and nutrient samples. We've also, I forgot to mention here, we also have qPCR sampling for the past 2 years as well. And then I'm hearing some interference. Make sure that folks have muted. And so we've also, since we don't have buoys at these systems for a variety of reasons, we've also collected vertical profiles when we haven't had access to a boat on Odell and Crescent Lakes and Crane Prairie as well. And then again, we compare these field data with satellite estimates of cyanobacteria abundance derived from the Sentinel-3 satellites. So with the cyan products that we've talked about earlier today. Just to give a sense of some of the continuous measurements that we've been collecting, I want to show a series from Crescent and Odell Lakes, since that's the longest time series that we have. And this is surface water samples, the surface water profile, just for, that's where we can have our sondes affixed. And so on these graphs, on the x-axis is Julian day, 1 through 365 in terms of day of the year. And then I've graphed the minimum daily temperature taken from the sondes across the previous 3 years. And what's interesting here is you can see that for both 2019 and 2020, we saw a pretty similar pattern in terms of the minimum daily temperatures that we saw throughout the year. Whereas this past year, you can definitely see the effect of the heat dome event that happened in late June of 2021. And so you saw surface temperatures spiking with our minimum daily temperatures about 2 weeks prior to where they had been the previous 2 years, which was interesting and thought maybe a harbinger of an earlier bloom. However, what's interesting here, so I'm showing again Crescent and Odell Lake, and Crescent, just for reference, usually hasn't had a documented bloom, whereas Odell has. And Crescent's been our control essentially. But here I've plotted again on Julian day versus maximum daily phycocyanin values recorded at the sonde level, at the sondes. And what you can see is that in 2019 and 2020, we did see a spike, and there were documented blooms, and we issued advisories for elevation of microcystin samples that were collected, or OHA did. What's interesting here, though, is that 2021, again, got really warm pretty quickly, but no bloom ever manifested based on the sonde data, and also you'll see the satellite data throughout the course of the season. Just to get a sense of the type of satellite imagery, here's Odell from 2020, and you can definitely see over the course of mid-July through early August how the bloom, for one, formed and concentrated without the lake. And just as a reference, our sonde is located here at Sunset Bay. And so you can see that the bloom, as per typical in Odell, tends to concentrate on the eastern or southeastern side of the lake based on wind patterns. But again, it also just completely dropped and disappeared within a day or two, which is also typical, which is also an interesting question of why that occurs. But you can see with the satellite imagery, similar pattern to the phycocyanin values. You saw that at least at the lake level, you could see that there was a spike in cyanobacteria abundance similar to what we saw with the phycocyanin measurements. I'm taking too much time from Alyssa here, so let me just quickly go through this and say that The satellite estimates seem to be corresponding pretty well. I'm using the term HCB here, harmful cyanobacteria bloom, pretty well. The only thing that I'll mention is, I'm showing 2 water bodies and one with a bloom, but there does seem to be some, in terms of the quantitative relationship between the satellite measures and the water and the field measurements. There seems to be some variation among water bodies and probably maybe across year, but why that's the case, there's a few different reasons, using different scales of measures, as well as different calibration of equipment from year to year and water body to water body. So we're still exploring that.